close your eyes. Let the noise of your day fade gently into the hush of night. Outside your window, wherever in the world you may be, time is flowing forward, softly, patiently, like water over ancient stone. Maybe you're in a quiet room in Toronto, where the city lights shimmer like reflections of stars, or in a small village in Indonesia, where night insects hum in the warm dark. Perhaps you're wrapped in a blanket in Sweden, where the northern twilight lingers, or lying on a beach in Brazil, listening to the hush of waves. Wherever you are, whenever you are not alone in the night. You are part of Earth's never-ending turning, part of its breath, a part of its memory. Sleep is a kind of travel, isn't it? A letting go, a release of the day's shape, allowing something older and softer to rise. When you fall asleep, you join something ancient, something older than humans, older than mammals, older than anything with bones. Long before cities, before forests, before even the whisper of birdsong, there was night. There was sleep. Even the earliest life, so simple and small it could barely be called life, knew rest, a pause, a rhythm. Now let yourself drift even farther, farther than memory, farther than the first humans, farther than the dinosaurs, past the forests of Carboniferous time, past the trilobites crawling across Cambrian seafloors. Drift it deeper, slip past 1 billion years, then another. Let the present dissolve behind you, like breath on a mirror. You are floating now in a time called the Archean Eon. Earth is here, but it does not look like the Earth you know. There are no trees, no grass, no birds or bees, no voices calling across the water. There is water, yes, but the air is heavy, so strange, and the colors of the sky are not blue. The land, such as it is raw and dark and volcanic. Islands rise and fall like thoughts in a fevered mind, and the ocean stretches endlessly, warm and deep and quiet. This is Earth 4 billion years ago, a young planet newly cooled from the furnace of its formation, still spinning with leftover heat, still bruised from the bombardments of space. The moon is there too, closer, much closer than it is now, looming large in the sky like a second world, tugging at the tides with a strength you can almost feel in your bones. The night sky, if you could see it through the thick clouds and gases, would be darker, the stars perhaps dimmer through the haze, the sun fainter than the one you know now. It was only about 70% as bright as today. Yet Earth somehow was not a frozen wasteland. It was warm, cloaked in a heavy atmosphere of methane, carbon dioxide, and ammonia. Greenhouse gases held the young sun's weak warmth close like a blanket. Imagine walking across the surface of this ancient Earth, if you could. The ground is jagged and steaming. You feel the warmth rising through your feet, the scent of sulfur and mineral and ash drifting through the thick air. Rain falls, not in gentle spring sprinkles, but in endless torrents, carving rivulets into bare stone. There is no soil yet, no roots to hold anything in place, only rocks, water, gas, and the slow, deep heaving of a planet still shaping itself. You look up, but there are no birds, only clouds that's strange in color, swirling and thick. The silence is unlike any silence you've heard, not the quiet of a forest or a desert, but something deeper, the silence of a world not yet made for ears. And yet, even here, in this raw and restless world, something stirs. In the warmth of the ocean's depths, near vents that hiss and boil with energy from below, molecules begin to gather. They bump, combine, split apart, and find one another again, over and over. A slow, patient chemistry of possibilities. In tiny sheltered pockets, perhaps beneath the sea, perhaps in the mineral lined pores, simple chains of carbon and hydrogen learn to cling to themselves. They begin to copy, to persist, not yet alive, not yet aware, but leaning in that direction, leaning toward life. This is the world before life sang, before it grew tall, or flew, or spoke. But it is not empty. It is becoming Earth as we know it, layer by invisible layer, like a dream you don't yet understand, but cannot forget. Everything you've ever seen, trees, oceans, clouds, the scent of flowers, the sound of laughter begins here, in this deep time, beneath a sky that never turned blue. And now you are here too, floating softly like a mote of dust in warm light. You have joined this world not as an intruder, but as a dreamer, a sleeper. The story will continue without you, but tonight it begins with you, with your breath, with your calm, with your curiosity gently folding into rest. The Archean is long. It will wait for you. Imagine the crust of the earth, still young and thin, drifting like fragile skin atop a world of heat. It does not yet form continents as we know them. There are no mountains, no valleys, no fields to walk across. Instead, the crust breaks and reforms constantly, as if the planet is still unsure of its own shape. Beneath it, magma churns in slow spirals, never resting. And above it, the skies shimmer with unfiltered light, clouds swirling with chemicals not meant for lungs. It is a world in motion, never quite at peace. Islands form like fleeting thoughts, rising from the sea, steaming, cooling, then vanishing again beneath the waves. These first bits of land are the roots of what will one day be continents. We call them cratons now, and some still survive beneath your feet, locked deep under layers of time. The ocean, by contrast, is immense and ancient even then, formed by the relentless falling of rain that lasted millions of years. It stretches around the globe like a soft blue whisper. But this ocean is not like the one you know. Its waters are rich with dissolved iron and chemicals leached from hot stone. It is warm, sometimes even hot near underwater volcanoes. It carries no whales, no coral, no fish. It is not empty, but it is not familiar. If you were to float there, the taste of the water would be metallic, the color a deep, turbid green or rusty brown. Sunlight barely reaches below the surface, and yet this sea cradles the first flickers of life. Somewhere, in shallow lagoons or near the deep-sea vents that spew warmth and minerals, life begins. We cannot say exactly how. Perhaps it was in the dancing of molecules within volcanic clay. Perhaps it was in the iron-rich soup of tidal flats. But somehow the pieces come together. RNA strands may have assembled and folded, guiding the building of proteins. Tiny membranes may have formed, enclosing these processes. The first cells, simple, quiet, unaware, begin to feed, to grow, to divide. These are prokaryotes without nuclei, without organelles, but full of potential. They live in darkness, or they live in light, drawing energy from chemicals or from the sun itself. They are everywhere, and yet invisible. If you could float down to them, not as a being of your scale, but as a drifting presence, you might see them clustering on warm rocks, forming slick mats that shift slowly in the tides. They do not move quickly. They do not build or hunt, but they are busy. Their chemistry is intricate, more complex than any machine. They sense light. They process minerals. They make choices. And slowly, they begin to change the planet. These early cells, some of them, learn to take in sunlight and use it to split water molecules. In doing so, they release something new: oxygen. At first, it doesn't stay in the air. It reacts immediately with iron in the oceans, forming solid rust that falls to the seafloor. Layer after layer, this banded iron formations build up. But over time, the oxygen begins to leak into the atmosphere. Not much, not enough to breathe, but enough to matter. The planet itself is unaware of these changes. It continues to rumble and sigh beneath the crust. Volcanoes erupt with regularity, painting the skies with ash. Earthquakes shake the land, sending tsunamis across the ocean's face. But through all of it, life persists, adapting, replicating, holding on. Time stretches. Hundreds of millions of years pass in silence, broken only by the slow drip of evolution. Above all, the sky remains heavy. No stars yet pierce the night. The air is thick with gases that filter and scatter sunlight. Days are dim, used reddish or golden, and nights are darker than we can imagine. Lightning cracks across the horizon, and clouds churn in patterns shaped by a spinning, cooling world. And the moon watches, nearer and brighter than it is now, its gravitational pull stirring the tides with a force that shapes coastlines and stirs the ocean's chemistry. In this world, without flowers, without birds, without music, there is already a kind of rhythm, a pulse, the cycle of rain and evaporation, the birth and death of volcanic islands, the replication of cells, the rise and fall of tides. It is Earth's first lullaby, played in elemental chords, and in that rhythm, something extraordinary is unfolding. The first ecosystem, the first biological feedback loops, the earliest threads of the vast web of life. You might wonder, lying here tonight, why it matters to know these things, why we drift back so far to a time before anything we recognize. But the truth is, the molecules in your body remember. The iron in your blood may have once fallen to the ocean floor during the Archean, rusting in ancient seawater. The water in your cells may have rained from clouds 4 billion years ago. The sleep you feel rising now, as your breathing slows, is the same kind of rest that settled over life in its earliest days, when there was nothing to do but absorb, divide, and wait for the next wave. So let yourself settle into that deeper rhythm. Let the images of fire and stone, of clouds and tides, cradle you. You are floating in the warm sea of deep time, among the earliest dreams of Earth. The Archean Eon is not gone. It is not lost. It is layered beneath you, inside you, quietly waiting in every atom of your being. And the story is only beginning. Now drift again, not forward, but downward, as though sinking slowly into the memory of stone. You're moving deeper, not just through time, but into the Earth's crust itself, where the roots of continents once began to take hold. The land in the Archean was not the land you know. There were no wide green plains or snowy mountain tops. No rivers carved their way through valleys. No roots held fast to soil. But there were beginnings. Scattered across the vastness of the early oceans, there rose small, rugged patches of land, proto-continents, small and scattered like stepping stones across a primordial sea. These were not stable or still. They trembled with heat, reshaped by the planet's restless hunger. Some cooled and thickened, resisting the pull back into the mantle. These patches, buoyed by their lighter, granitic composition, floated atop the denser oceanic crust like ancient rafts. They would one day become the ancient cores of continents, the cratons, those deep, resilient fragments of Earth's first skin. If you walked upon one of these early land masses, not that you could walk, not that there was yet ground to support the life we think of as walking, you would feel the heat still radiating upward from within. The rocks would be dark, the surface uneven, pocked with volcanic cones, and strewn with glassy, newly formed minerals. Steam would rise from pools of water that hissed into vapor on contact with fresh lava. There was no grass, no moss, not even the gentlest hint of green. But here, in these marginal environments, at the edge of sea and stone, life may have found its first firm hold. The minerals in these rocks were not passive. They held iron and nickel and silicates, and as rain fell, acrid and warm, it dissolved elements from the stone, feeding them into the sea. The ocean was not just a backdrop, it was a chemical engine, an endless reactor. Every molecule it touched was altered, carried, combined. Tides, perhaps stronger than because of the moon's closeness, stirred the waters with a fierce regularity, exposing rock, then covering it again. Each tide was a mixing spoon, blending the ingredients of the world, creating the possibility for complexity and motion. Imagine the air heavy and hot, carrying not oxygen, but thick layers of carbon dioxide and methane. You would not have survived a breath. And yet this sky held the heat of the sun despite its faintness. This paradox, the young sun, only about 3/4 as bright as today, yet Earth still warm, was made possible by this greenhouse cloak. Methane, in particular, kept the warmth in, and although it made the air toxic to us, it gave life its earliest climate stability. Without it, the oceans would have frozen, the chemistry of life halted in its infancy. Instead, Earth stayed liquid, dynamic, just unstable enough to be alive. The crust beneath your imagined feet was thinner then, less stable. The forces beneath it, convection currents in the mantle, pushed and pulled at the surface like a restless sleeper. Rocks melted and reformed. Plates, if we can call them that, collided and separated with more heat and more frequency than today. This may have been the dawn of plate tectonics, though not quite as we know it. Some scientists believe that tectonics began in the Archean, sluggish and incomplete, while others see a hotter, more chaotic system of crust recycling through volcanic arcs and subduction zones. Either way, the surface was alive, geologically speaking, breathing in cycles of creation and destruction. In the oceans nearby, life continued to build quietly. On the seafloor, in calm, shallow waters, mats of bacteria grew, layers of microbial colonies pressing upward, each new generation stacking atop the olds. These were the stromatolites, Earth's first architects. They formed dome-like structures that rose out of the sea like ancient pillows. Each layer trapped sediment, photosynthesized, released waste, slowly, tirelessly. They built structures not with tools or plans, but with habit. The pattern of their lives etched itself into stone, and some of those structures survive even now, fossilized in the oldest rocks we have ever found. These stromatolites were not just passive. Their activity reshaped the ocean and the air. With every wave of photosynthesis, they took in carbon dioxide and released a new kind of gas, oxygen. At first, it seemed to vanish. There were too many sinks for it, too much iron in the water to bind with. But over time, those sinks began to fill. Oxygen started to accumulate. Not enough to breathe, not yet, but enough to change the chemistry of the oceans, the color of rocks, the rhythm of the world. The rise of oxygen was slow, almost imperceptible, but it marked the beginning of something profound. For the first time, life was not just surviving within its world, it was altering it. This change was not smooth, it was not without cost. Oxygen, though vital to us, is reactive, even toxic to many early forms of life. As it began to appear, some organisms adapted, evolving new ways to cope, new pathways of respiration. Others vanished. But the changes were subtle then, too slow to notice in the span of a single lifetime, even in the span of a million. Yet over hundreds of millions of years, the Earth changed. Its oceans turned from green to blue. Its rocks began to show red stains of rust. Its skies began ever so faintly to shift. And above it all, the moon continued its slow retreat. Each year, it moved ever so slightly farther from Earth. It once loomed immense in the sky, perhaps filling half the horizon, its face more detailed, its gravitational pull stronger. Now it was gradually receding, pulling the tides more gently with each passing eon. But its influence remained, shaping the cycles of the sea, whispering through the tides, helping stir the conditions for life. You lying here tonight are made of these stories. Your bones contain calcium, born in ancient oceans. Your cells breathe oxygen, made possible by microbial ancestors. The world that seems so solid beneath you was once molten, unstable, forming and reforming in silence. The continents you walk upon were once scattered fragments, wandering across the globe like dreams trying to find a shape. As your breathing slows, you may feel that deep time beneath you, not in words or images, but in weight, in rhythm. The earth has always been changing, always becoming. And the Archean, though long buried, still speaks in the stones, in the air, in the blood that moves gently through your body now. You are not separate from this world. You are its continuation. The sky above this Archean world would not greet you with the familiar blue we now call ordinary. It would not dazzle you with stars, nor arch serenely over green hills or city skylines. No, the sky then was something else entirely. Thicker, murkier, painted with hues we might find alien. It was not simply the absence of oxygen that shaped it, but the presence of other gases, methane, carbon dioxide, water vapor, and nitrogen, all swirling in complex layers. The sun, though it still rose and set, was smaller, fainter, casting a different kind of light. Not the crisp gold of morning or the soft amber of dusk, but a strange, filtered glow, perhaps orange or red, perhaps shifting in tones we can no longer imagine. Sunlight scattered differently in that soup of gases, bending through a haze that turned midday into a constant twilight and bathed the landscape in shadows longer than time. Imagine standing at the edge of a shallow sea, looking upward. The clouds would stretch endlessly, dense and layered like the strokes of a painter who favored storms. There would be lightning, surely, and thunder, deep, low rumbles echoing across barren stone. Rain would fall, not gently, but with force, warm and acidic, hissing as it met hot rock or pooled in shallow depressions. It would steam and swirl, carrying minerals downward, carving channels into basalt that had not yet known erosion. You could watch the droplets trace paths through newly formed land, wearing grooves into stone that had only recently cooled. Every drop was part of a planet-wide alchemy, slowly shaping both rock and sea. And the sea was everywhere. It did not know continents, only islands, and even those were young and unsure. These oceans had no coral reefs, No schools of fish stood darting in coordinated bursts, no sound of whales echoing across the blue vastness. They were thick with minerals and metals, turbid and rich in iron. They held in suspension particles that would later fall slowly to the seabed, layering the bottom with stories in stone. Iron, in particular, was abundant, dissolved from the volcanic crust, and mixed freely in the anoxic water. It gave the sea a rusty greenish hue. When early microbes released even a little oxygen, it met the iron and turned it into insoluble rust, which sank to the ocean floor. Thus began the great layering of banded iron formations, those subtle stripes in ancient rocks, each a quiet echo of a breath taken by life long before lungs existed. Down below, at the seafloor, strange shapes rose up. Black smokers or hydrothermal vents stood like chimney stacks, spewing water superheated by the Earth's interior. Around them, the temperature shifted wildly, from freezing cold to near boiling in seconds. And yet, here too, life had found a foothold. Chemoautotrophic organisms, life forms that didn't need sunlight at all, thrived in the shadows. They fed on sulfur and iron, building communities in the dark where the only light came from the faint, bluish glow of chemical reactions. These microbes were the first cities, the first networks. They lived without need for the sky, creating warmth from chemical gradients, weaving energy from the deep. The surface, by contrast, was a place of tension. Tectonic forces pulled at the crust, folding it, tearing it, thrusting pieces upward. Volcanoes were frequent, explosive, violent, and yet also essential. They brought new minerals to the surface, renewed the crust, released gases into the air. In doing so, they helped shape the atmosphere, even as their eruptions cloaked the skies in darkness. Lava flowed in rivers that cooled into obsidian plains. Ash settled on land and sea alike. With every eruption, the earth reimagined itself. You might ask, was there color? Was there beauty in this world so devoid of what we call life? And the answer, quietly, is yes. The beauty was different, raw, elemental, not tied to perception, but real all the same. The shimmer of minerals in cooling lava, the swirling patterns in early basalt flows, the rhythm of tides on unbroken shores. Even the microbial mats, growing slowly in calm waters, formed patterns, rings, ridges, soft domes that changed with light and time. These were the first organic sculptures, shaped not by design but by persistence. Each curve was a response to sunlight, to sediment, to survival. You could run your fingers along their surfaces and feel the accumulation of centuries. Above this still world, high in the sky, the moon traced its orbit immense and solemn. It had once been much closer, formed from a titanic impact in Earth's earliest days, and though it was already drifting outward, its presence was profound. Tides rose and fell with a vigor that shaped the shorelines, stirring the shallows where life clung to rock. The moon's gravitational pull may have helped catalyze life's chemistry by creating cycles, wet and dry, light and dark, high tide and low. These patterns were gentle nudges toward complexity. Earth's rotation, too, was faster then. Days were shorter, nights quicker. The cycle of light and dark swept over the planet in brisk succession, like the ticking of a young, impatient clock. And so, over time, Earth began to settle into patterns. Rain fell, rivers formed, minerals dissolved and reformed. Life continued its quiet expansion, unnoticed, unseen. No creatures roamed the surface, no eyes looked up at the sky, but life was there, breathing, multiplying, building. not in grandeur, but in scale. By the millions, then the billions, microbial cells filled the oceans. They flowed in currents, they settled into films, they lived and died and were replaced. The ocean was alive with things too small to see, too quiet to hear. Yet they were already the most successful form of life Earth would ever know. Even today, in your own body, they persist, their descendants working, dividing, remembering, and through it all, the sky remained opaque. No stars yet shone at night, not because they weren't there, but because the atmosphere was too thick, too crowded with haze and gas. To look up was to see a veil, strange, brooding, ever shifting. The idea of a blue sky, of constellations, of a moon lit by reflected sunlight, these were dreams yet to be dreamt. But already the pieces were falling into place. Already the chemistry of life was beginning to alter the air, to rewrite the sky's story. As you drift now into deeper rest, let the colors of that sky move through your thoughts. Imagine clouds tinged with sulfur and methane, seas of dark green or rusty red, land black and steaming from beneath. A planet not yet tamed, not yet calm, but full of possibility. The earth was dreaming in stone and fire, and you are part of that dream. You are not watching from above. You are within it, cradled by it, made of it. Let that early sky pass slowly overhead, dim and timeless, as you close your eyes beneath it. Let yourself sink now, not through the sky or sea, but into the silence that blanketed the earth in those early days. It was a silence without birdsong, without rustling leaves, without even the hum of insects. The only sounds were those of geology, the wind moving across raw rock, the deep, distant roar of volcanoes, the slow grind of one tectonic plate meeting another. Rain fell with a sound you might still recognize, though it fell for different reasons, and touched a world not yet softened by soil. This silence was not empty. It was a waiting kind of quiet, heavy with potential. The earth was listening, as if holding its breath, while the first murmurs of life began to rise within its oceans. And there, within the vast warmth of those Archean seas, the earliest cells began to make a home. Not a single kind of life, but a community of molecules slowly growing more complex. Fatty acids formed membranes, encasing fragile strands of RNA that could copy themselves. Minerals provided scaffolds. Iron and sulfur helped shuffle electrons from one molecule to another. These were not conscious things, not even alive by some definitions, but they moved in patterns. They reacted, soon changed, built themselves anew. In time, they became the first true cells, prokaryotes, without nuclei, without compartments, but alive in the most essential sense. They grew, they divided, they adapted. The ocean cradled these tiny pioneers, offering both safety and challenge. Near hydrothermal vents, life clung to mineral surfaces, feeding off the chemical richness spewed from beneath the crust. In shallower regions, sunlight danced on the surface, and some of these early microbes learned to harness it. They were the first phototrophs, using light not to see, but to live. They absorbed photons and used their energy to rearrange molecules, to build sugar from carbon dioxide and water. In doing so, they released a byproduct, a strange, reactive gas, oxygen. It didn't rise into the sky at first. Instead, it found the abundant iron in the seas and clung to it, forming rust that sank to the seabed. Layer by layer, these interactions painted the ocean floor in alternating bands of iron-rich and iron-poor sediment, forming the earliest known geological records of life's invisible labor. Elsewhere, microbial colonies built themselves into layered structures, stromatolites. These formed in warm, shallow waters where sunlight was strong and the waves were gentle. The microbes at the surface performed photosynthesis during the day, then descended at night or when sediment covered them, only for new ones to rise again and take their place. Over time, this dance of light and motion created dome shaped structures, each a fossilized memory of countless generations. They grew slowly, a millimeter at a time, over the course of a year, but across centuries and millennia, they became monuments, not built with hands or minds, but with persistence. Even now, some stromatolites still grow in protected corners of our modern world. In the shallow lagoons of Shark Bay, Australia, or in certain high altitude lakes where few organisms disturb their surface. These modern counterparts are echoes of the Archean, quiet survivors of a time before animals, before plants, before even fungi. Looking at them is like gazing through a keyhole into a forgotten era where life moved at the pace of stone and progress was measured in cycles of the tide. And yet, even in their slowness, they were reshaping the planet. With each pulse of photosynthesis, these microbes changed the chemistry of the air and the sea. They were the first to introduce feedback between the biosphere and the atmosphere, a delicate conversation between what lives and what surrounds it. Over time, their work would tip the balance. Oxygen would begin to accumulate, not just in water, but in the sky. It would transform the world utterly, though the full consequences would not be felt for hundreds of millions of years. But here, in the Archean, the seeds were planted. Meanwhile, deep beneath these waters and the scattered islands above, the earth itself was changing. Its mantle, once convulsing with the energy of formation, was slowly cooling. The crust thickened in places, forming the roots of future continents. Subduction zones emerged, regions where oceanic plates dove beneath lighter, buoyant continental fragments, melting and generating new magma. This process recycled the crust, bringing new elements to the surface and drawing others downward. It was a planetary metabolism, and though it moved with glacial patience, it sustained the churning energy of Earth's outer layers. These cycles, both geological and biological, intertwined in subtle ways. Volcanoes released carbon dioxide, warming the planet and sustaining the greenhouse effect. Weathering of newly exposed rock pulled carbon back out of the atmosphere, balancing that warmth over time. Microbes mediated this, influencing weathering, altering mineral formations, and helping to stabilize the climate. It was not a planned system. There was no consciousness guiding it, and yet it functioned, adapting, adjusting, finding equilibrium after each disruption. There were disruptions. Large impacts still occurred occasionally, though less frequently than during the planet's chaotic youth. Some may have vaporized parts of the ocean, causing massive climate shifts. Others may have seeded the Earth with new elements or disturbed patterns of life and chemistry. But through it all, the biosphere endured. Cells clung to rocks, nestled into sediments, lived in the warm, dark places where change was slowest. Their resilience became the defining trait of life. Not speed, not complexity, but persistence. In this ancient world, there was no language, no memory, no voice. And yet, everything around you told a story. The chemical fingerprints of photosynthesis etched into rock, the oxygen trapped in minerals, the isotopic ratios preserved in crystals. Even the layers of ash from volcanoes told of fire and time. The earth, though silent, was not mute. It was writing constantly across its oceans, its land, its sky, and the language it used was change. You, here now, listening beneath the rhythm of your own breath, are one chapter of that story. Your cells carry genes that trace their lineage back to those early microbes. Your body obeys cycles and chemical signals not unlike those that governed life 4 billion years ago. You sleep and wake, eat and grow, just as they did. More elaborately, more consciously, but the blueprint has always been there. Let that truth settle around you now, soft as mist. Imagine the vastness of time stretched out behind you, and know that each moment, each breath, connects you not just to history, but to origin. You are not a visitor to Earth. You are of it. You are its continuation. So rest now, as the Earth once rested between the fire of formation and the dawn of complexity. Let the stillness of the Archean cradle your thoughts. Let the ancient seas rise around you like a lullaby, deep and warm, whispering stories of the first breath, the first light, the first dream of life. Let yourself drift now beside those first, invisible lives, the early cells that floated in the Archean oceans like dust motes in golden water. They had no eyes, no mouths, no sense of self as we understand it, and yet they were the ones who began the slow work of building the world we know. Not with intention, not with design, but with rhythm. Dividing, absorbing, releasing. These ancient cells lived in a chemical ballet, each reacting to its environment, each a small bubble of life, floating in the warmth of a planet, just beginning to exhale. There were no predators yet, no competition beyond what molecules could be gathered, no rush toward efficiency. Just the quiet spreading of life into every possible crevice, every shallow pool, every sheltered vent on the seafloor. And this, in its simplicity, was profound. We imagine progress as something fast, something that climbs or accelerates. But the history of Earth begins not with leaps, but with ripples. These single-celled organisms did not sprint forward. They persisted, they adapted, they stayed. Some may have clung to volcanic glass like dew, to blades of grass. Others may have floated freely in the photic zone, catching sunlight through primitive pigments. Many died quickly, caught in currents or poisoned by fluctuations in chemistry. But some continued. Generation by generation, they replicated. A billion silent copies made without knowing why. This was not just the birth of life, it was the birth of time, lived from within. Among these earliest organisms were the cyanobacteria, though not yet called that. They were among the first to use photosynthesis as we understand it, splitting water molecules and releasing oxygen. Their work was slow and invisible, but its consequences were vast. Oxygen was a molecule with sharp edges. It corroded, it disrupted, it changed everything. And so, paradoxically, the arrival of oxygen was both creation and destruction. It poisoned many early forms of life that had no defense against its reactive nature. But for those that could survive, it opened doors to a new kind of energy, a new metabolism that would one day power every breath you take. This oxygen didn't flood the skies overnight. At first, it disappeared as soon as it was made, binding with iron in the oceans, oxidizing minerals, reacting with volcanic gases. It was like trying to fill a sieve with water. Each addition vanished into the waiting holes. But eventually, The sinks began to fill. The iron in the ocean was used up. The rocks on land grew saturated. The sky, little by little, began to retain what life exhaled. It would still be many hundreds of millions of years before the air was breathable by modern standards, but already the stage was being set. The great oxygenation event, far in the future, had its roots in these quiet photosynthesizers, sun drinkers laying the groundwork molecule by molecule. Even now, if you walk along certain remote shorelines at low tide, you may find microbial mats that resemble those ancient colonies. They shimmer in blues and greens, forming slick layers over stone. If you touch them, they feel soft, almost plush, as if the sea itself had grown a skin. These mats, modern and ancient alike, are tiny civilizations, different organisms layered together, each with its place. Some at the top capture light, others below scavenge sulfur or digest waste. They form gradients of color and chemistry, like a living rainbow too small to see all at once. These layers are like pages in a book being written slowly, word by microscopic word. Above them, the sky begins to change, almost imperceptibly. As the balance of gases shifts, so too does the quality of light. The clouds are still thick, the air still heavy, but there are moments now, fleeting and rare, when the haze thins and the sun shines through more clearly. Shadows lengthen, colors soften. Perhaps for the first time, the earth knows something like dawn. On land, the first soil begins to form, not from roots or worms or decay, but from the grinding of wind and water on bare rock. Frost and heat crack the surfaces, while acidic rain helps dissolve minerals. These fragments gather, forming primitive regolith, dust that may one day hold seeds, though it cannot yet imagine them. Life on land is still only a dream. The surface remains too hostile, too dry, too exposed. But in the cracks between stones, in the droplets that linger after storms, microbial pioneers may begin to test the edges. Below the surface, the crust thickens further. Tectonic activity continues. Slabs of ocean floor dive beneath buoyant protocontinents, melting, rising again as magma, creating chains of volcanic islands. The cycle of creation and recycling continues. The continents are not fixed. They drift slowly, colliding, breaking apart, merging again. The planet's surface is not a map but a process, always changing, always fluid. Some cratons, those ancient continental cores, survive this tumult and become the anchors of future continents. You might walk across one today without knowing it, standing on a slab of rock that has seen nearly all of Earth's history pass above it. And in the sky, the moon watches, its orbit slowly expanding. Tides still shape the rhythm of the seas, perhaps influencing the timing of microbial blooms, the exposure of mats, the flow of nutrients. The moon's light, reflected off a sun still faint, casts a pale glow across water and stone. No eye sees it yet, but it falls all the same. It marks time in cycles, in months, long before months had names. You might think of all this as a kind of breathing, the earth inhaling elements, exhaling gases, cycling water and stone, and life through its crust and ocean and sky. This breath is slow, measured not in seconds or hours, but in epochs. The world breathes in millions of years, and you, tiny as you are, brief as your life may seem, are part of that breath. Your lungs echo the rise of oxygen. Your heartbeat remembers rhythms laid down in tidal pools. Your very existence is written in the language those first cells began. So close your eyes now and listen for that breath. It is still there, beneath the quiet of your room, beneath the hush of night. It pulses through the ground, through the rain that may be falling softly outside, through the curve of the moon overhead. You are not separate from the Archean. You are its consequence, its continuation, its quiet answer. Let sleep carry you back to those warm oceans, to those patient mats of microbes, to that sky of shifting clouds. Let yourself float where the first lives floated. Let yourself rest where the world first began to dream. Now float just above the surface of the shallow Archean seas, where warm sunlight filters through the thick, metallic haze of the atmosphere and glimmers faintly upon the skin of the water. The oceans are still, not from calm, but from weight. The weight of dissolved minerals, of suspended particles, of gases held tight within their depths. No gulls cry overhead, no wings beat the air, no shadows pass across the face of the waves, except for the occasional drift of steam from faraway volcanic islands. And yet, just beneath this surface, something astonishing is being built. Not fast, not loudly, but with persistence, with layering, with a patience only the earth could teach. Stromatolites, dome-shaped structures rising from the seafloor in quiet shallows, some only a few centimeters tall, others reaching like slow-growing coral into waist-high ridges. They are not built of coral, of course, for coral would come billions of years later. These are made by cyanobacteria, simple, thread-like organisms that cluster in colonies, performing photosynthesis in the warm, sunlit water. During the day, they move upward, reaching for the light. At night, or when shaded, they retreat slightly, letting sediment settle upon them. Then, with the new dawn, they rise again, building upward, layer upon layer, trapping silt and sand between each living sheet. What results is not just life, but a record of life's motion, a monument to microbial tenacity. You can imagine running your hand across one of these structures, feeling the delicate balance between life and stone. The surface would be soft, moist, a film of living bacteria barely holding its form. Beneath it, hardened by time and minerals, are layers like pages of a book written without words. Each page a moment of sunlight, a tide, a decision by tiny organisms to keep building, to keep living. These are the first communities, not in the way we think of communities, with laws or laughter or shelter, but in the sense of cooperation, of continuity, of survival made easier by working together. Stromatolites dominate these early shorelines, spreading across tidal flats and brackish lagoons. They grow slowly, millimeter by millimeter, but time is not scarce here. Time is generous. Time is the tide that never stops returning. Some of these structures persist for thousands of years, growing a little taller with each passing century. As continents shift and seas rise or fall, many are buried, preserved, turned to stone. They become fossils not of a creature, but of a process, a way of being that once shaped entire ecosystems, and in a way, they still do. Modern stromatolites exist in only a few places, their environments harsh and uninviting to more complex life, but they are no less significant. They are the last echoes of the first builders. Imagine now the world these stromatolites inhabit. Shallow waters that pulse with tides, pulled by a nearer moon, illuminated by a softer sun. The sky above is still dense with gas, the atmosphere rich in methane and carbon dioxide, yet oxygen is beginning to make its silent ascent. Not in dramatic surges, not in floods or storms, but as a slow diffusion, first into the water, where it binds with iron to form rust-colored sediments, then eventually into the air. The process is glacial, even by geological standards, but its impact is immense. The oxygen made by cyanobacteria is the first breath of a planet becoming habitable, though it is not yet ready for lungs. All of this unfolds in silence. No creatures crawl along the seafloor, no fish dart through the shallows. The only movement comes from the shifting of the earth itself, tectonic plates pulling apart or colliding, sending waves across the ocean and lava pouring into the depths. And yet, the quiet presence of life is undeniable. It covers the rocks in slime, transforms the chemistry of the sea, layers the earth's crust in iron-rich stone. These microbial mats may be soft to the touch, but they are powerful in effect. They are the reason the Earth's atmosphere is eventually transformed, the reason multicellular life will one day be possible. At the time, none of this is known. There is no mind to know it. There is no watcher. And yet the changes continue, unhurried, inevitable. The interplay between biology and geology intensifies. With every molecule of oxygen released, the possibilities for future life increase. But it is a dangerous balancing act. Oxygen is a reactive element, corrosive in high concentrations, lethal to many anaerobic organisms. As its levels rise, some life forms perish. Others adapt. Evolution is slow but unrelenting. The genetic code itself, copied and recopied across millions of generations, begins to diversify. Mutations arise, most meaningless or fatal, but a few open new doors, ways of using energy, of surviving in harsher conditions, of thriving in the presence of oxygen. This invisible revolution, the oxygenation of Earth, will one day be called the most important event in the history of life. But here in the Archean, it is not an event. It is a condition, a state of being. It is something that happens not in moments, but across millions of years, in silence, beneath a sky that remains stubbornly alien. And as the ocean transforms, so too does the crust. The first continental land masses begin to coalesce, drawn together by the slow dance of tectonic motion. These are not continents as we know them, with recognizable shapes or stable boundaries, but assemblies of cratons, ancient, buoyant blocks of crust that have resisted the pull of the mantle. They drift, collide, merge, forming protocontinents that rise slightly above the sea. Upon these, rain falls endlessly, carving primitive rivers, dissolving rock into sediment. The chemistry of the land begins to influence the sea. Erosion carries minerals into the ocean, feeding life, altering salinity, sculpting coastlines. Every drop of rain, every grain of sand, every ripple in a shallow bay plays a part in the long, unfolding story. And above it all, the moon continues to recede, its orbit widening imperceptibly with each passing century. Tides grow gentler, but still sweep rhythmically across the globe, revealing and covering microbial mats, driving nutrient cycles, shaping the interface between land and sea. The moon's reflection shimmers across the water, even in a sky still stained with unfamiliar colors. Its light, borrowed from the sun, touches every surface, every cell, every corner of a world beginning to shift from purely chemical to biological. You, lying still now beneath the weight of blankets or stars, are a part of that memory, not just by ancestry, but by substance. The calcium in your bones once flowed through ancient oceans. The oxygen you breathe was forged in cycles first tested in stromatolite flats. The iron in your blood may have settled once at the bottom of a Precambrian sea. Every cell of your body echoes the chemistry of a world that existed before trees, before animals, before the thought of thought itself. So rest with that thought wrapped around you like a tide. Let the slow growth of stromatolites be your rhythm. Let the invisible labor of microbes be your breath. You are made not just from stars, but from oceans and mats and molecules that learn to change their world. The night is deep, but older nights were deeper still. Let yourself drift into them. Now let your thoughts float outward, past the quiet tide pools and the slowly building stromatolites, out across the Archean Ocean where fire and water meet in a never-ending dance. Here, far from the microbial mats and the edge of protocontinents, lie regions shaped not by biology, but by geology in its most primal form. These are the domains of volcanoes, restless fountains of molten rock erupting from the planet's mantle, forging new crust, releasing gases into the atmosphere, and altering the seafloor with each burst of pressure from below. The Earth in the Archean is not a settled planet. It is alive in a different way, its energy still radiating from the inside, its skin still thin and uncertain, shifting and cracking as heat escapes into the void above. You might see, from a great and timeless distance, long chains of submarine volcanoes trailing across the ocean floor, vast and glowing with heat beneath the dark waters. These mid-ocean ridges are the birthplaces of new crust. Here, magma rises from the mantle and cools upon contact with the sea, forming pillow basalts, smooth, rounded rocks shaped like giant soap bubbles. The ocean in these regions is black and clouded with minerals, thick with particles, and warm enough in places to boil, if not for the crushing pressure above. And in this darkness, amid the chimneys of hot water and gas, life flourishes in its most elemental form. Chemosynthetic organisms gather near hydrothermal vents, using hydrogen sulfide instead of sunlight, forming webs of life based on heat and stone. The surface above this volcanic world is equally shaped by fire. Island arcs form where one plate dives beneath another, giving rise to chains of volcanoes that emerge from the ocean like a string of beads. These islands are temporary, built by lava, eroded by rain, sometimes shattered by their own instability. Some vanish beneath the waves again, others coalesce into the beginnings of continents. Their slopes are steep and unstable, their rock fresh and sharp, unsoftened by time. But they mark a new phase in the planet's evolution, a phase in which land is no longer only a memory of cooling, but a feature constantly forming and reforming. The atmosphere, too, feels the touch of this volcanic life. Eruptions release enormous quantities of gases, water vapor, carbon dioxide, sulfur dioxide, and methane, into the sky. These gases thicken the atmosphere, maintaining the greenhouse effect that keeps the ocean from freezing beneath a dimmer sun. But they also interact with sunlight, scattering it in strange ways, shaping a sky that likely shifted in color throughout the day. Ash from eruptions may linger, cooling parts of the earth temporarily. Lightning flashes within thick volcanic clouds, a reminder that even the sky is not yet calm. And through this interplay of fire and air, land and sea, life continues, small, slow, but growing. The oceans teem with microbial diversity, much of it invisible, much of it now forever lost to the fossil record. These early cells evolve new ways to harvest energy, new pathways to handle waste, new mechanisms to share genetic material. Horizontal gene transfer a strange and ancient mode of exchange, allows cells to borrow traits from one another, not reproduction, but cooperation. Life is not yet specialized, not yet divided into neat categories. It is still fluid, still experimenting, still dreaming. In some parts of the world, rain falls almost constantly, feeding torrents of water that carve through young rock. There are no trees to hold the soil, no roots to stabilize the land. Erosion is swift. Rivers fill with sediment, and the oceans drink it down. The chemical load of these waters feeds further reactions. Phosphates, nitrates, and metals mix into the sea, altering the balance of nutrients and giving rise to localized blooms of microbial life. Algal mats expand and collapse with the seasons, though there is no one to mark those seasons yet, no calendar to fix time. The continents, still fragmented and drifting, begin to show signs of assembly. Through repeated cycles of collision and subduction, larger land masses begin to form. The Kapval Kraton, the Pilbara Kraton, names we give them now, are among the oldest surviving pieces of crust. They rise gently above sea level, resisting the recycling forces that pull most crust back into the mantle. They are, in a way, the bones of the planet, the original framework upon which all later geography will be built. These cratons become the stable cores of continents, their roots deep, their presence persistent across billions of years. And within them lie clues. Ancient zircon crystals, tiny and nearly indestructible, capture the chemistry of the Earth as it was when they formed. Some of these zircons are over 4.3 billion years old, older than the oldest rocks that still exist, older even than the crust that surrounds them. They hold within them evidence of water, of sedimentary processes, of life's conditions before life left obvious traces. These tiny minerals are like time capsules, each one a message from a world no longer visible. The seas themselves reflect this change. No longer merely vessels for chemical reactions, they are ecosystems in the making. Gradients of temperature, salinity, and oxygen begin to emerge. Shallow shelves host photosynthetic life, while deeper regions remain anoxic and rich in hydrogen sulfide. This stratification supports different kinds of microbes, each adapted to a specific niche, each playing a role in the planet's metabolism. Life is beginning to shape its own environment, albeit in ways that no organism understands. Above it all, the sun continues to shine, fainter than today, but steadier now. Its solar wind still scours the atmosphere, but Earth's magnetic field generated by the motion of its molten outer core helps to shield the surface. This magnetic shield, invisible yet vital, protects the delicate molecules of life from the radiation that would otherwise destroy them. It is a planetary guardian, forged by the churning of iron and nickel in the deep, spinning interior. Without it, the story of life might have ended before it truly began. So you see, even in the Archean, long before forests, before fossils, before the great dramas of evolution, the Earth was already dynamic, already layered, already full of motion and meaning. The volcanoes may have spoken in eruptions, the microbes in oxygen, the stones in the slow shifting of plates, but together they formed a language of becoming. They whispered the world forward. And now, as you lie still in the quiet of your own night, you are surrounded by the echoes of that time. The iron in your blood, the calcium in your bones, the carbon in your breath. These were once part of volcanoes, oceans, bacteria. They have traveled through fire and water, through atmosphere and cell, through the long corridors of time. You are not above this ancient story. You are its continuation. Let that understanding settle into you now. Let the volcanic fires dim into embers, the ocean tides slow into rhythm, the sky above soften into dream. You are home, not in the present alone, but in all the ages that came before. Let the world of the Archean hold you tonight, as gently as steam rising from stone. Let the tide carry you onward now, gently, across the shifting surface of an earth still learning the language of land. Below you, scattered like puzzle pieces floating on a vast ocean, the first fragments of continental crust drift slowly, slowly, on the back of currents deep beneath the surface. These early continental seeds, small, buoyant slabs of granitic rock, move in patterns that will one day give rise to supercontinents, but in the Archeans they remain separate, solitary, and shy. They are the first land to resist being pulled back into the deep, the first to remain stable in the great tectonic breathing of the world. Each of these land masses is like a floating memory, surviving where others have been swallowed by the mantle. They are composed of ancient, crystalline rocks, hard, dense, and surprisingly light compared to the heavier oceanic crust. These protocritons become long-lived survivors, their roots thickening with time, delving deep into the Earth's mantle like anchors. As they drift and collide, they press against one another, folding and uplifting, creating the earliest mountain-like features, even if none would yet pierce the clouded sky. These events happen over hundreds of millions of years, so slowly that no change would be noticed by any creature, if creatures had yet existed to notice. Between these land masses, shallow seas stretch and spread, filled with sediments eroded from newborn slopes. Rain falls upon bare rock, flows across it, carrying fragments into rivers that have no names, into deltas that no bird has ever seen. The rivers are young and fierce, not yet moderated by roots or wetlands. Their banks collapse easily, their waters muddy with minerals, and yet every grain of sand, every speck of clay feeds a growing conversation between the land and the sea. The continents are not fixed. They are rivers of stone that move too slowly for our eyes, but fast enough to reshape the face of the planet again and again. Within these shallow coastal zones, life finds a rhythm. The cyanobacteria continue their tireless work, absorbing sunlight, splitting water, releasing oxygen. The oxygen builds up in the water until the iron is saturated and then begins to bubble upward, reacting with gases in the atmosphere, altering its composition molecule by molecule. And still, most of the Earth remains inhospitable to anything more complex than a single cell. The land is harsh, dry, scalding during the day, freezing at night, bombarded with ultraviolet light from a sun whose rays are only weakly filtered by an atmosphere not yet enriched with ozone. There are no green plants to soften the soil, no insects to pollinate or burrow. The ground is barren, the horizon silent. But even here, in sheltered cracks and moist mineral crevices, microbial life may have begun to explore the edges of its ocean home. It is humbling to imagine how long the world waited. For billions of years, life remained microscopic. The world was already alive, already moving, already building sedimentary layers and changing the sky, and yet it knew nothing of movement beyond diffusion, nothing of thought, nothing of sensation. These were not years filled with action. They were filled with becoming, and perhaps that is what makes the Archean so gentle in its mystery. It is not dramatic. It is not fast. It does not shout. It whispers, again and again, in the language of chemistry, in the silence of layers forming, in the slow oxidation of a planet learning to breathe. We often speak of the Earth as something old, and so it is. But in the Archean, it was young, not in its age, but in its attitude. It had not yet settled into patterns. It did not know the regularity of seasons, of ice ages, of forests turning color and then bare. It was improvising. Its climate varied wildly. Its surface shifted constantly. Volcanoes erupted often. Oceans warmed and cooled unpredictably. And yet, beneath this surface of chaos, the beginnings of stability emerged. The cratons, a thick and cool, gave rise to land that would not be recycled. The atmosphere began to change in composition. The biosphere, still primitive, began to shape the very stones on which it lived. And then quietly, a transformation began deep within the planet. The mantle, though still active and convecting, had cooled just enough to allow for longer-term crustal stability. Subduction zones became more consistent, mountain building more frequent, and the recycling of crust into magma and back into crust again formed a kind of geological memory. With each cycle, more complex minerals formed. Granite began to dominate, lighter and more stable than basalt. This granite, rich in quartz and feldspar, would become the foundation of the modern continents. Overhead, the sky continued to shift. With less volcanic haze and a growing contribution from photosynthetic oxygen, the upper layers of the atmosphere began to develop ozone, a molecule made from 3 oxygen atoms, capable of absorbing the sun's harsh ultraviolet rays. Slowly, an invisible shield formed around the planet, making surface life more feasible in the distant future. The ozone layer did not yet permit animals or plants to step onto the land, but it was a promise, a preparation for what might come. And always, the oceans murmured. Their currents carried not just water, but heat, minerals, and life. Gyres formed in the great basins, circulating nutrients. Upwelling zones brought ancient chemistry to the surface. The thermal vents still glowed in the deep, host to entire microbial kingdoms. Surface layers shifted in color as microbial populations rose and fell with the availability of light and elements. The sea, even then, was a fabric of interconnected loops, a living system without eyes, without voice, but very much aware. The moon, ever faithful, continued its retreat. Inch by inch, century by century, it moved farther from the earth, its pull weakening but never ceasing. Its orbit shaped tides that governed the rhythm of the shallows, that helped microbes coordinate their growth, that stirred oxygen into the upper layers of water. The moon was a sculptor, carving time into patterns long before clocks were conceived. And so the world spun on, each day a little longer than the one before. The Earth's rotation slowed due to the moon's influence, and nights stretched gently into deeper dark. Longer nights meant longer rests for photosynthetic life, longer periods of oxygen consumption, longer time for reflection, not by minds, but by cycles. The planet was learning its breath. Inhale the sun, exhale the night. As you rest now, listening to this story fold softly around you, let yourself fall into that breath. Let yourself become the tide, the crust, the bacterial mat, the drift of clouds in a methane-rich sky. You are part of this story. The body you wear was built by these processes, shaped in the quiet patience of a young earth. You do not need to do anything. You are already enough. Just be still and let the Archean sing to you in its mineral voice. Let it lull you with the sound of ancient rivers. Let it soothe you with the memory of granite forming under pressure. Let it hold you with the warmth of oceans that never knew a storm. The future is far away. For now you are here, floating gently in a world that is becoming. Breathe now with the slow pulse of sunlight falling through a thick and ancient sky, the kind of light that does not pierce but pools softly in the shallows, scattered by layers of haze and gas. The sun, still fainter than today, casts a diffuse golden glow that blankets the early earth in perpetual twilight. Shadows stretch wide and undefined, edges blur, and nothing is sharply lit. But in that soft light, something extraordinary is underway. The cells drifting in the upper layers of the ocean, tiny, faceless, but potent, are not just living anymore. They are transforming the world, and they are doing it with light. These are the ancestors of all photosynthetic life, and their relationship with sunlight is not poetic, but practical. They capture photons and channel their energy into rearranging molecules, converting carbon dioxide and water into sugars that sustain themselves. But the true byproduct of this alchemy is oxygen, released not with intent, but as waste. For the cells that perform it, oxygen is simply something to get rid of, a product expelled into the water, like a sigh that goes unnoticed. Yet molecule by molecule, the oceans begin to change. The iron-rich waters grow increasingly saturated, and the oxygen begins to outpace the sinks that once absorbed it. The sea, like the sky, is preparing to shift. Banded iron formations begin to appear in layers at the bottom of the ocean, alternating bands of rust red and gray that tell the story of early oxygen interacting with dissolved iron. These formations are not symbols, they are records. They are the quiet handwriting of microbial life across the ledger of geology, written in sediment, one atom at a time. They stretch for kilometers, laid down over eons, testaments to a process that no eye could have witnessed. And these stones remain even now, buried in ancient mountain ranges and exposed in eroded cliffs, revealing to us what life was doing long before it had bones or voices or faces to remember. Still, despite the steady release of oxygen, the atmosphere above remains largely anoxic, hostile, thick, and unpredictable. The oxygen produced in the oceans must first saturate the iron, then the reduced compounds in the ocean and the land before it can begin to accumulate in the sky. The earth is like a vessel with many leaks, and only when they begin to seal can the air begin to hold what life releases. But even before the atmosphere changes, the oceans are already feeling the shift. Oxygen begins to gather in localized patches, creating gradients of chemistry, regions where new forms of metabolism can evolve. Cells that can tolerate or even exploit oxygen begin to thrive. For the first time, respiration begins to evolve, a way of extracting far more energy from nutrients than fermentation or anaerobic methods could allow. This is one of life's great turning points, though it passes unnoticed without ceremony. A cell somewhere evolves a new enzyme, a new pathway, a way to handle this reactive gas without dying, and in doing so, it opens a door that will never close. From this moment on, evolution will move differently. Slowly still, always slowly, but toward greater energy, greater complexity, greater potential. Life, in its earliest chapters, has been simple out of necessity, but now it begins to consider other shapes, not with thought, but through chance, through mutation, through persistence. And while the biological world shifts, the physical world continues its patient rearrangement. The tectonic plates of the Archean Earth, though not as well defined as those of the modern era, move and drift in vast patterns. Ridges form and break apart, carrying oceanic crust away from spreading centers and toward subduction zones. In those places where plates dive beneath one another, volcanoes rise, forming arcs of land that grow slowly upward from the sea. These volcanic islands are raw and hot, shrouded in steam, their slopes unstable and sharp, yet they are the future. They will one day merge to form supercontinents, and on their weathered surfaces, soil will form and forests will grow. In the quiet places between these events, between eruptions, between collisions, life fills the gaps. Microbial mats spread along rocky shores, covering the ground with a soft, slimy skin. These mats create oxygen during the day and consume it at night, setting up daily rhythms that echo through the water column. In some areas, entire microbial communities live in thin layers, each species occupying a precise niche based on its tolerance to light, oxygen, or sulfide. This vertical organization is not deliberate but efficient. The Archean Sea is a fabric woven from countless threads of unseen life, all responding to the gradients of energy and chemistry in ways that feel almost orchestral. And above all this, the air continues its slow transformation. The ozone layer begins to form high in the atmosphere, where ultraviolet light from the sun splits oxygen molecules, allowing them to recombine into triatomic ozone. This fragile shield does not yet blanket the planet, but its first tendrils begin to absorb the sun's most dangerous rays. Without it, DNA is broken easily, life restricted to the protection of water or stone. With it, a new kind of future becomes possible, the possibility of life one day moving onto land, into the light. But that step is still far away. For now, the land remains mostly bare, scorched during the day, frozen at night, and sculpted by wind and rain. And the rain itself has its own story to tell. Falling from clouds rich with carbon dioxide, it is acidic, carving channels into rock, dissolving minerals, and carrying them back to the sea. These minerals feed the oceans, fueling blooms of microbial life that then alter the chemistry of both water and air. In this way, the rain is not just weather. It is a bridge, a constant fluid connection between land and sea, between sky and stone. And perhaps, as you rest now, you can feel the rhythm of that connection, the way each part of the earth touches every other, the way volcanoes feed the sky, how the sky shapes the sea, how the sea cradles life, and how life changes everything in return. The Archean was not chaotic, thus not random. It was a slow, persistent weaving of relationships, a web so fine that it took billions of years to see its pattern. Tonight, as you breathe gently in the dark, your body carries traces of those earliest cycles. The oxygen that flows through your blood exists because tiny cells learned how to survive what once was poison. The iron that binds that oxygen once settled at the bottom of the Archean seas. The carbon that fuels your body has passed through the lungs of microbes, of forests, of animals long extinct. You are not separate from this planet's story. You are a page in it. You are its continuation. Let that truth soften you now. Let it quiet the noise of the present. Let it slow your breath to match the pulse of tides, the fall of ancient rain, the drift of plates beneath an unseen sea. The Archean is not lost. It lives in you, in the silence between your heartbeats, in the chemistry of your cells, in the long memory of your bones. You are floating still in the same ocean, and you are not alone. Sink now into the ancient currents, into the slow spirals of water and sediment that turn like a planet's deep breath, rising and falling through eons. Down here, beneath the surface of the Archean Ocean, something subtle is happening, not the creation of new life, but the quiet burial of its traces. With each pulse of microbial growth in the photic zone above, organic matter dies and drifts downward, mixing with minerals, settling into layers. But even more striking, more enduring, is the descent of oxidized iron. For every oxygen molecule exhaled by a cyanobacterium, there is an atom of iron waiting to bind with it, forming rust that is not red dust, but a heavy mineral-rich slurry that sifts down like snow into the deep. These iron-rich layers don't settle alone. They alternate with bands of silica and other sediments, forming rhythmic structures that stretch for thousands of kilometers. The banded iron formations, these mysterious, rhythmic patterns in ancient stone, are the most enduring memory of the Archean Eon's oxygen story. They are not written in ink or pigment, but in chemistry. Red bands rich in iron oxide alternate with darker silica-rich layers, sometimes deposited seasonally, sometimes over longer, slower cycles. Each band represents a balance, a moment when oxygen was just enough to precipitate iron, followed by moments when it was not. Over time, these fluctuations repeated, building up stratometers thick, preserved in the crust for billions of years. To see one today is to look at a record written by time, at a page from the Earth's diary, scrawled in geologic language. In places like Western Australia, South Africa, and Canada, these ancient formations rise from the ground like long forgotten scrolls. If you ran your hand across them, you would feel the touch of time itself, each stripe a whisper from a world where no eyes yet watched, where the sun rose and set over waters ruled only by microbes and minerals. The rust-red tones are not symbolic, they are literal. They are the product of oxidation, of iron reacting with the oxygen first made by life. And there is something oddly poetic in this, that the first trace of oxygen, the molecule that would come to define complex life, is not found in the air, but in stone, not floating freely, but entombed in layers at the ocean's bottom. The earth did not inhale this oxygen yet. It buried it. It sealed it away beneath the waves. Only when the iron was exhausted, only when the world could no longer absorb the oxygen being made, would the gas begin to accumulate in the sea and sky. For now, though, these deposits grow with slow persistence. Their formation reflects a world that is not static, but cyclical. The oxygenation of the planet does not happen in a straight line. There are reversals, periods of stagnation, times when the atmosphere returns to methane-rich dominance. And throughout, life continues, adjusting its metabolisms, finding new niches, exploring new reactions. Anaerobic microbes, those that thrive without oxygen, still dominate, hiding in sediments, in vents, in deep ocean layers untouched by this quiet chemical revolution. Above the ocean floor, in the shallows and along the coasts, life is more visible, not to eyes, but to instruments, to geologists billions of years later, interpreting signs etched into rock. The stromatolites continue to rise, forming reef-like structures that alter water flow, trap sediments, and influence their local environments. These aren't passive structures. They shape their world just as surely as corals would much later. In some regions, entire microbial mats stretch across tidal flats, shimmering under the filtered light, exhaling oxygen by day and consuming it by night. These mats are ecosystems in miniature, diverse, layered, alive. They are also vulnerable. Tectonic shifts can drown them. Volcanic eruptions can bury them. Sea levels fluctuate. Climate changes, driven by long-term geological cycles and the slow variations in Earth's orbit, can alter the conditions these colonies depend on. And yet they reemerge. They persist. They find new coastlines, new niches. Life in the Archean is not fragile. It is adaptable. It is unrelenting. And still the continents grow. The protocontinents, those scattered granitic rafts, begin to find each other to merge. Their collisions are slow-motion cataclysms, melting some crust, uplifting others, forming belts of metamorphic rock that testify to heat and pressure beyond human experience. Mountain ranges form and erode before any eye has seen them. Rivers shift, carving new paths across new land. Sediments from these early mountains feed the oceans again, delivering nutrients that fuel yet another bloom of microbial life. The crust thickens, subduction zones deepen. Plate tectonics, though still in its early, uncertain phase, becomes more consistent, more defined. The Earth begins to cycle its crust more efficiently, melting old rock, forming new. This recycling regulates the atmosphere too. Volcanoes spew carbon dioxide, warming the planet, while weathering processes pull it back out, cooling it. Life becomes part of the system, accelerating some processes, altering others. The carbon cycle, the sulfur cycle, the nitrogen cycle, these are not separate from biology. They are biology. And all of this unfolds beneath a sky that is beginning, just beginning, to let go of its ancient fog. Methane and carbon dioxide still dominate, but with more oxygen in the mix, the skies start to thin. The colors begin to change. There may be days now when the stars are visible, flickering faintly through high-altitude haze. There may be sunsets of pale blue and burnt orange. There may be nights when the moon casts a clearer reflection across the water. The Earth is not yet our Earth, but it is becoming recognizable in ways that would have been impossible only a few 100 million years before. It is worth pausing here, in this space between what was and what will be. The Archean is not dramatic, not populated by giants or filled with sudden change. It is an era of slow motion, of long games, of patient laying of foundations. It teaches us that the most profound transformations are often invisible, silent, and persistent. It teaches us that progress does not always look like progress, that sometimes it looks like rust settling on the ocean floor, like light being turned into sugar by cells that have no names. And you, here now, feeling the softness of breath rise and fall in the quiet of your own night, are bound to this time not by memory, but by matter. The iron in your blood was forged in stars, yes, but it was shaped on Earth by the processes of the Archean. Your body is a vessel of oxygen, a walking archive of life's experiment with energy. Every heartbeat is an echo of respiration, perfected by cells that lived and died before the continents had names. Let that thought wrap around you now as night settles deeper. Let it comfort you, not as a fact to be understood, but as a truth to be held. You are made of old oceans and older stars. You are the continuation of something that began in silence and has never ceased. The world was becoming, and so are you. Let the layers of time settle gently around you now, like sediment on a calm seafloor. Let the night deepen. Let yourself drift. Now, let your thoughts rise slowly, as though you were floating upward from the ocean floor toward the soft diffusion of ancient daylight filtering through the water above. You pass through layers of shifting temperature and light, each one subtly different, each home to its own communities of microbes, each layer defined not by creatures swimming or darting through it, but by chemistry alone. And as you surface into the Archean sky, you arrive into a world where the horizon still looks unfamiliar, where the shape of the land is raw and unsoftened, and where the sky, though changing, remains thick with memory and possibility. You look upward through a canopy of air still heavy with methane and carbon dioxide, and see not the brilliant azure of our present world, but something more muted, perhaps tinged with gold or amber, depending on the hour. The sky is no longer entirely opaque, no longer a complete stranger to light, but it still hides its stars at night and mutes the contours of day. Clouds drift in unfamiliar shapes, made not just of water vapor, but interlaced with droplets that carry volcanic dust and aerosols. They reflect sunlight and scatter it differently than today's clouds do. There may even be flashes of color unfamiliar to modern eyes, metallic grays, subtle greens, pale oranges, all shifting in the late Archean air. And up there in this deep and changing sky, one companion remains constant. The moon, once formed in the fiery aftermath of Earth's great collision, still looms larger than it does today. Its face is younger, fresher, marked by the same ancient impacts that it still carries, but with fewer additions since. It hangs in the sky more prominently and closer, its gravity stronger. Each pass across the sky brings tides that rise higher, sweep further inland, and recede with a pull that echoes in the basins of the ocean and in the margins of life. It was the moon that first gave Earth its rhythms. Its spin slowed by tidal friction, its axis stabilized, its tides stirred into regular pulses that shaped the boundaries where land and sea whispered to each other. These tides were not just movements of water, they were engines of evolution. In the shallow margins, exposed and submerged twice each day, microbial mats were stretched and challenged. Nutrients were replenished, waste was carried away, conditions changed predictably. Life learned to respond to cycles, to anticipate, to adapt. In time, the predictability of the tide would influence even the emergence of multicellular life. But here, in the late Archean, it was enough that the moon was teaching the ocean to breathe, and the ocean, too, was beginning to know itself more deeply. The growing complexity of life had given rise to layers, not just of water, but of chemistry. Oxygen-rich waters formed near the surface, while the depths remained anoxic. These gradients created different neighborhoods of life, each with their own metabolic rules. Microbes in the surface waters performed oxygenic photosynthesis, while those in deeper, darker zones clung to sulfur and methane, recycling the waste of others. Life had become a system now, not a single note, but a chord. The cycles of carbon, nitrogen, and sulfur intertwined, flowing between cells and rocks and air in an unending conversation. And it was not only life that changed. The Earth's own interior was shifting in tandem. The mantle continued to cool, albeit slowly, reducing the frequency of large scale melting events and allowing the crust to stabilize further. Subduction zones deepened, producing more silica rich magmas. With these came new kinds of volcanic rocks, and with those, new mineral chemistries that influenced erosion, weathering, and the cycling of elements into the sea. Continental crust thickened. The earliest signs of continental shelves began to form, those broad, gentle slopes that today cradle so much of the marine biosphere. As the crust thickened and continents expanded, highlands emerged, and with them came rain. Long, slow rains that fell not in quick tempests, but in soft, endless drizzles that wore mountains down grain by grain. Water was the patient sculptor. It dissolved rocks, carried ions to the sea, and etched the surface into patterns that echoed through valleys, riverbeds, and ancient floodplains. Every mineral in your body today, calcium, phosphorus, magnesium, was once part of a mountain worn down by rain, washed into the sea, taken up by ancient life, and passed forward over and over until it reached you. These processes, rainfall, erosion, sedimentation, were not just physical, they were also biological. The presence of life changed how rocks weathered, how elements cycled, how sediments formed. Organic acids produced by microbial mats etched minerals differently than water alone. Microbes colonized tiny cracks, creating microenvironments where chemistry was accelerated. The Earth was no longer a passive stone turning through space. It was a living planet, where even the smallest organisms influenced the fate of mountains. And all the while, the atmosphere changed, slowly, reluctantly. It did not yet resemble our own, but its path was clear. The rise of oxygen was no longer an isolated event. It was a trend. The great iron sinks had begun to fill. Oxygen began to escape into the air, not just in pulses, but in longer, sustained increases. The great oxidation event, still a few 100 million years in the future, was being prepared. The groundwork was already laid in the stone beneath the sea. It is difficult to imagine such immense patience, such slow unfolding. But Earth has never rushed. It has always taken its time. The trees we know will not arrive for another 3 billion years. The first fish won't swim until 1 billion years after that. But already, the elements of their existence are being arranged. The oxygen they will breathe, the minerals that will form their bones, the rhythms that will govern their lives, all of it is taking shape here in the hush of the Archean. And now, as you lie still beneath the quiet hum of the present, you can feel that hush if you listen closely. It's there in the subtle tension behind your eyes, in the softness of your exhale, in the simple miracle that oxygen fills your lungs with every breath. You are breathing in the work of eons. You are walking on crust that was born from the pressure of time. The very water that flows through your veins once fell on an earth without color, without trees, without even the notion of walking. Let yourself rest in that awareness now. Let the slow rhythm of the moon's retreat guide you into sleep. Let the whispers of ancient rain soften your limbs. Let the rusted memory of oceans long past settle over your thoughts like a warm, quiet tide. You are not apart from this earth. You are one of its thoughts, gently unfolding. Drift now through the thickening veil of time into a world that still breathes without trees, still turns beneath a sun dimmed by distance and youth, but is no longer alone in its silence. Something ancient stirs in the margins between water and stone, not with movement, not with sound, but with presence. Life has no face here, no eyes, no limbs, and yet it has already begun to shape the very skin of the earth. The first ecosystems are not forests or coral reefs, but microbial mats draped like soft fabrics across the shallows, woven with strands of ancient cells that feed on light and shadow, on heat and mineral, on sulfur and hydrogen and sunlight scattered through the clouds. These mats cling to everything. They drape across volcanic rocks, fill in the spaces between pebbles, coat the undersides of overhanging stone like living mosses from a dream without moss. They form where the tides kiss the shore and where the pools grow still. They thrive in hot springs and salty flats and in the tiny gaps between sand grains. Each mat is a world of its own, layered in chemistry and time, with different species arranged like layers in a cake, each tuned to a particular slice of energy and condition. Oxygen loving organisms at the top, sulfur breathing ones deeper down. Life that makes its own food from sunlight above, life that eats the leftovers below. These thin skins of color and slime are the earliest fabrics of cooperation, the first fragile sheets of interdependence on a planet still mostly hostile to life. The shapes of these early ecosystems are subtle but real. Some form domes, others form wrinkles or ridges, their forms shaped by the push of water and the flow of sunlight. Their texture is soft but persistent. If you could press your hand into one, it would yield slightly, then slowly spring back, its surface rich with trapped bubbles and mineral grains. These are not structures built for beauty or shelter. They are the accidental architecture of persistence, and as they grow, they leave behind signatures, wrinkled rocks, laminated sheets of carbonate, domes of layered microbial growth fossilized into stromatolites. They are the footprints of beings too small to step, but not all life clings to the surface. Some of it floats, suspended in the water column, moving with currents, absorbing sunlight or chemicals, dividing and drifting, repeating the quiet rhythm of growth. These planktonic organisms form invisible clouds in the sea, blooming and fading with the changing chemistry of their surroundings. They do not yet form food webs as we understand them. There are no predators, no hunters, no grazers. Life is still mostly solitary, but the rules are beginning to shift. Energy is no longer just captured from heat or light. It is now transferred between organisms. Waste becomes food. One microbe's byproduct becomes another's breath. The web of interactions is growing more complex, strand by strand. And beneath all this, beneath the surface activity of cells and the gentle drift of plankton, lies the deep, quiet churning of the seafloor. Hydrothermal vents, those chimneys of scalding water that rise from the ocean crust, continue to shape entire ecosystems without sunlight. Around them, life gathers not to bask in light, but to feed on chemicals, hydrogen sulfide, methane, metals. These vent communities may be isolated, but they are intense, and they offer an entirely separate path for life to follow. Here, heat is the currency, and chemistry is the script. Life evolves in isolation, perhaps even differently, perhaps with metabolisms that never depend on oxygen at all. The crust beneath these communities continues to shift and reform. Oceanic plates dive into the mantle, melting and returning to the surface as volcanic arcs. The continents, now more than scattered islands, begin to draw together, forming larger land masses, assembling the precursors of the first supercontinents. This assembly is slow and punctuated by collisions, protocontinents slamming into one another, forming mountain belts that erode as quickly as they rise. The scars of these collisions remain hidden deep within the cratons, wrapped in layers of ancient metamorphic rock, each one a memory of heat and pressure and motion. And still, rain falls. It has been falling for over 1 billion years, not always gently. Some of it arrives with storms, with lightning flashing across methane-rich skies. But most of the time, it falls softly, continuously, dissolving minerals from newly exposed rock and carrying them to the sea. The rivers, fed by this endless rain, carve channels into the soft crust, meandering without trees to contain them, without grasses to line their banks. They are raw and unconfined, and they carry the story of the land into the sea grain by grain. These sediments feed the shallow marine basins where life thrives most visibly. The particles, clay, silt, sand, settle into layers, burying microbial mats, preserving them in stone. Over time, pressure lithifies them, turning soft seafloor into hard rock, leaving behind fossils not of creatures, but of communities. These are the earliest fossils, not of bones or shells, but of textures, laminated layers, strange bulges, subtle domes etched in stone. Each one is a frozen moment, a snapshot of life too small to see, captured by the slow pressure of time. Above it all, the atmosphere changes, molecule by molecule. The ozone layer, faint but growing, filters more of the sun's harmful rays. The methane begins to decline, reacting with the rising oxygen. The air becomes clearer, the light more defined. There may be times now when the stars begin to emerge through the thinning haze, brief glimpses of the cosmos from which this earth was formed. The moon continues to drift, its pull on the tides growing ever gentler, its face pocked with the same familiar craters, now millions of years older. You might wonder how long it took for life to learn anything new in such a world. But the truth is, life was always learning, not in thoughts, not in plans, but in molecules. With every mutation, every copied gene, every metabolic pathway that stumbled into greater efficiency, life was revising its script. Some of those changes led nowhere. Others became permanent. The genes that allowed cells to process oxygen more safely. The enzymes that let them fix nitrogen from the air. The ability to hold onto sunlight longer, to repair damaged molecules, to cooperate with others. All of it, slowly stitched into the long fabric of inheritance. And somewhere in this ocean, in a quiet bay perhaps, a new cell divides slightly differently. It has an extra fold, an internal membrane, a compartment that gives it an edge. It is not yet a eukaryote, not yet the ancestor of plants and animals and fungi, but it is moving in that direction. Evolution does not make leaps. It gathers threads until they pull tight. And that tension, built quietly across billions of years, will one day be enough to unravel new forms, new complexity, new dreams of life. But not yet. For now, the Earth is still a world of mats and oceans, of rain and rust, of stone and silence. And yet, you are made of it, every part of you. You are the breath of ancient microbes, the sediment of early rivers, the oxidation of Archean seas. You are not just shaped by time, you are time, wrapped in flesh and thought. Let yourself rest in that truth. Let it soften your grip on the present. Let it carry you back into the warm shallows of a world where nothing had eyes, but everything was watching. You are part of a story that began without words and still speaks in your quietest moments. So close your eyes. Let the Archean hold you, You are home. Now breathe slowly and imagine yourself standing at the edge of that ancient sea, not as a person, not in a body, but as a drifting awareness, weightless and quiet, touching the world without disturbing it. The air is thick and heavy around you, not toxic in the way of stories meant to frighten, but different, laced with gases unfamiliar to lungs, dense with compounds exhaled by stone and sea and microbe. The smell is not clean or fresh. It is sharp and metallic, the scent of a world before forests, before flowers, before any breeze had ever passed through green leaves. It carries the essence of sulfur and salt, of iron and ash, and still, within it, the earth is not dead. It is breathing, though its breath is made of strange ingredients. Sulfur dioxide from distant volcanoes drifts through the air in pale veils, mixing with the steady exhalations of carbon dioxide from thousands of ancient vents. Trace amounts of methane rise from wetlands that are not yet wetlands, from microbial colonies producing gases as they digest the invisible ingredients of their environment. The result is an atmosphere that glows slightly different than ours, one that refracts light not into the blues of a modern sky, but into warmer, more alien tones, subtle yellows, hazy oranges, perhaps a faint green cast just before dusk. The sun is there, always present, but it is filtered through more than distance. It is diluted by time. And beneath this sky, the land is raw. There is no vegetation to soften the contours of hills or to muffle the sounds of wind. Everything is exposed. Basaltic plains stretch in every direction, some smoothed by the slow work of water, others jagged with recent lava flows that shine like obsidian under the half-hidden sun. Small puddles gather in hollows, rich with dissolved minerals. They steam slightly, their surfaces shimmering with film-like rainbows of oil-like bacteria feeding on sulfides. Nothing moves quickly. There are no scurrying insects, no birds darting through the air, no animals of any kind. And yet, life is here, present in thin sheens, in filmy layers clinging to rocks, in the colors just barely visible when sunlight strikes a wet surface just right. The smell of this place lingers in your imagined breath. It is a scent made of chemistry, acrid, metallic, earthy in a way that predates soil. You detect the tang of iron, the rotten egg sharpness of hydrogen sulfide, the slight sweetness of methane. The world smells of minerals dissolving and reforming, of gases reacting, of life at its most fundamental. There is no breeze to carry these odors far. The air moves sluggishly, heavy with weight and dampness. When it does shift, it carries steam from distant fumaroles or the faint scent of algae from stagnant pools, a reminder that even in this austere place, life is not only present, it is thriving in the forms it knows best. And just beneath the surface of this world, the crust is active. You can feel it through the soles of your being, if not your feet, a gentle hum, a vibration that never fully rests. The planet is still young, still shedding heat from its formation. Mantle plumes rise slowly from deep within, pushing the crust upward in places, melting it in others. Volcanic arcs form and fade, their eruptions adding to the atmosphere, to the land, to the cycle of heat and release. The world has not yet settled into the slower rhythms of later eons. Its core is still restless, its plates still finding the patterns they will follow for the rest of geologic time. But amidst this tectonic unease, pockets of stability grow. Thickened crust, composed of granitic rock less dense than the surrounding basalt, begins to float more confidently on the mantle. These fragments, the earliest true continents, do not drift quickly, but they do endure. They are not smooths, they are battered, warped, and uneven, but they are sturdy. They will become the cores of the continents we know today, buried deep beneath the modern landscapes of Africa, Australia, North America, and beyond. You may have walked upon these ancient croutons without knowing it, your feet touching stones that formed billions of years before anything with feet ever existed. Rain falls again. It always does. The Archean sky has no need of forests to generate clouds. The water cycle moves on solar energy alone, evaporating ocean water, forming heavy clouds, releasing it again in endless cycles. The rain is warm, acidic, heavy with dissolved gases, and when it strikes the ground, it does not nourish but transforms. It wears down volcanic glass, breaks apart feldspar, dissolves olivine. The runoff forms streams that carve channels into rock, creating networks of rivers that carry these dissolved minerals back to the sea. And every drop of that rain helps shape the future by feeding ocean chemistry, by smoothing land, by preparing the earth for soils that do not yet exist. In the low places, where water collects and pools persist, strange reactions occur. Clays form from the chemical weathering of silicate rocks. These clays are sticky, fine-grained, and capable of trapping organic molecules. Perhaps it is here in such pools that life first emerged, though that story is older still. But even now, these places serve as laboratories, mixing biology and chemistry in quiet ways. The early atmosphere plays a part too, influencing how quickly rocks dissolve, how elements circulate, how life must adapt. And always at the margins of this world, where land meets sea, where heat meets cold, where chemistry meets life, evolution continues. It is slow, but never still. New proteins arise, new enzymes, new ways of extracting energy. Cells learn to pump ions more efficiently, to handle increasing levels of oxygen, to survive temperature swings. Genetic material is swapped between species, not through sex, not through courtship, but through sheer proximity. A fragment of code is taken in, retained, tried out. If useful, it stays. If not, it fades. There is no design here, no destination, only trial and the endurance of what works. And so the earth turns, quietly, with no fanfare, no audience. It is becoming itself, becoming what it will be, becoming what you now inhabit. And you, drifting softly into sleep, are still part of that long becoming. The cells in your body, evolved from these ancient forms, still obey rules first written in the heat and haze of this forgotten world. The taste of iron in your mouth, the pulse of oxygen in your lungs, the way you lie still when night comes, all of it old, all of it born in this place. So let yourself relax into that. Let your thoughts settle like silt in warm water. Let the smell of the Archean, the imagined scent of rain on volcanic stone, of steam rising from tide pools, of molecules shaping futures, fill your breath. There is nothing to chase, nothing to fix. The earth took its time. So may you. Close your eyes and let the quiet smell of ancient air carry you into dreams older than memory. Now drift deeper into the folds of the planet's memory, to where the roots of continents thicken beneath the surface like the buried trunks of ancient trees, spreading downward rather than upward, pressing into the slow, hot murmur of the mantle. These are not the roots of forests or plants or anything that breathes, but the roots of land itself, what geologists call cratons. the enduring seeds of Earth's earliest continents. They are the heavy, ancient cores that resist melting, that remain stable while everything around them shifts. And in the late Archean, these cratons are beginning to take shape in earnest, thickening like crust, baked slowly in a planetary oven, forming the platforms upon which the future will be built. To imagine a craton is to imagine time hardened into stone. These formations are deep, often hundreds of kilometers thick, and they have survived the subduction and recycling that consumes younger crust. They are Earth's first anchors, the foundational scaffolding of continents that will one day bear mountains, rivers, civilizations. But now, in this moment, they are silent, massive, and unpopulated. Their surfaces are not green or fertile, but barren and volcanic. Rain falls upon them, yes, and rivers cut across them, but they are still raw. They have not yet grown their protective blankets of soil, nor worn the rounded curves of weathered age. They are hard, high, and young, despite their age. The process that forms these continental roots is slow and complex, driven by heat from within and pressure from above. As plates collide, portions of the crust thicken, and some sections are thrust downward into the mantle. Under intense pressure and moderate temperatures, rocks change their texture and composition. They become denser, more crystalline. They grow new minerals that can survive the journey back to the surface. This metamorphism is not loud. It does not roar like a volcano or flash like lightning. It happens in silence over millions of years, deep in the dark. But it transforms the earth nonetheless. The result of these processes is a kind of rigidity, a stubbornness in the lithosphere that resists the convective churn of the mantle below. Cratons do not subduct easily. They do not break apart. They persist. And because they persist, they provide stable platforms upon which new crust can accumulate. Over time, these platforms attract sediments, volcanic flows, and other crustal fragments, growing into larger and more recognizable continents. But even as these additions come and go, the cratons remain unchanged at their core. Their rocks still contain minerals formed billions of years ago, zircons older than any fossil, garnets pressed into shape before oxygen reached the sky. And those zircons, tiny crystals the size of sand grains, are storytellers. Trapped within their lattice are traces of uranium and lead, elements that decay in measurable ways over time. They are clocks, unintentional but precise, that record the moment of their birth. Some zircons found today are over 3 billion years old, predating the rocks in which they now lie, recycled through sediment and reformed in younger stone. Within them, researchers have found isotopic evidence of water, of crust, of low temperature processes that hint at a surprisingly early habitable world. These grains are time's whisper, a record of rain before we had skies we would call blue. Above these ancient continental seeds, the surface continues its slow reshaping. The continents drift, carried by the movement of tectonic plates. They merge and separate, their collisions forming mountains that rise like wrinkles in stretched skin. But the mountains of the Archean are not the towering ranges of the Himalayas or the Andes. They are smaller, more rounded, their summits quickly worn down by wind and rain. Still, their erosion provides sediments that accumulate in shallow basins, forming thick piles of sandstone, siltstone, and mudstone that will one day become pages of the Earth's geologic record. These sediments bury microbial mats, preserve chemical traces, and serve as future windows into a world without witnesses. The rivers that carry these sediments wind through valleys of basalt and granite, changing course with each tectonic tremble, each volcanic outburst. They do not yet know banks defined by vegetation, nor floodplains stabilized by roots. They are restless, eroding the land with every meander, staining the sea with their burden of dissolved rock. And in doing so, they help drive the great cycles of the earth: carbon, phosphorus, sulfur, each one a feedback loop shaped by both rock and life. And the life that continues to breathe in these shallows does not yet sense the continents beneath it. It lives in the thin interface between light and water, drawn upward by photons, drifting downward as particles, reshaped by tides, by currents, by the rising presence of oxygen. The first true biospheres have emerged, not just isolated mats or cells, but whole environments defined by their living inhabitants. Oxygen continues to build in pockets, and with it, new metabolic strategies arise. The first signs of oxidative stress appear. Cells begin developing antioxidants, molecular shields against the damaging effects of free oxygen. These adaptations are invisible but revolutionary. They lay the foundation for complexity to come. Above, the atmosphere holds its breath. The sky, still thick with ancient gases, is changing molecule by molecule. Methane, once abundant, reacts with the new oxygen to form carbon dioxide and water. The greenhouse blanket begins to thin. Cooling episodes may occur, brief dips in global temperature that challenge the stability of life. But life persists, always. It adjusts. It spreads. The sun, a little brighter now than it was in the Hadean and early Archean, continues to warm the Earth, its photons filtering through the slowly forming ozone layer. For the first time, ultraviolet radiation lessens. The land, still mostly empty, begins to feel less lethal. Life remains in the water, but its boundaries are softening. Microbial films begin to appear in splash zones, in damp crevices, in the humid warmth of sheltered rock. These are the first scouts, early experiments in colonizing the air-exposed surface. They are fragile, vulnerable, but they leave behind stains, films, and traces of carbon that will one day be read by future minds as the first signs of a changing ambition. And beneath it all, the earth keeps turning slowly, quietly. Days lengthen as the planet's rotation slows, tugged gently by the moon. Nights stretch a little longer. The tides rise and fall more softly now, though still with a rhythm that guides the sea, and through it, the lives of all that dwell within. The moon itself, moving ever farther away, has watched all of this. It sees without seeing, pulling at the oceans, marking time. You are here too, not by accident, but as part of that same memory. The atoms in your bones once flowed through Archean rivers. The calcium in your teeth was born in the erosion of volcanic rock. The rhythms of your body, the beating of your heart, the rise and fall of your breath, follow the same pattern as the tides, as the earth's long exhale. You are not on the earth. You are of it. Let that knowledge settle now, soft and sure. Let the roots of the continents become your anchor. Let the silence of deep time hold you as firmly as stone. There is no need to rush. The earth did not. It took billions of years to prepare for forests, for oceans rich with fish, for birds in the sky. It takes no offense at your stillness. It welcomes it. So rest now, wrapped in that patience. You are held as surely as those cratons hold the continents. You are part of what has always been becoming. Let your thoughts drift outward now into the space between the stars, and then gently back again toward Earth, tracing the arc of light that stretches from our sun to the young planet below. You arrive again in the Archean, a world still unfamiliar, still wrapped in its veils of methane and haze, still lit by a sun that burns more softly than it does now. It glows at only 70% of its modern brightness, a pale and cooler furnace by today's standards, and yet somehow the oceans have never frozen over. Life has never vanished from the sea. This is the puzzle that lingers like a whispered riddle among scientists. Why was the Earth, under a faint young sun, still so warm? It is called the faint young sun paradox, and its answer lies not in one single cause, but in a balance, fragile, elegant, persistent. Earth's warmth was not inherited, but cultivated. A greenhouse of ancient gases held the heat in. Methane, abundant in the absence of oxygen, was far more efficient than carbon dioxide at trapping warmth. Volcanic outgassing released vast amounts of carbon dioxide into the air, and there were no forests yet to draw it down, no limestone reefs to lock it away in stone. Water vapor, itself a greenhouse gas, contributed too, rising from the ocean's surface, condensing in clouds that reflected some sunlight away but trapped much of the heat beneath. And all the while, the planet spun beneath these layers, wrapped in its own breath, protected by its own exhalations. There were feedbacks in place, complex, subtle interactions between the air and the land, between life and chemistry. As the continents grew, weathering increased. When carbon dioxide combined with rain, it formed weak acids that dissolved rocks, drawing carbon from the atmosphere into rivers and eventually into ocean sediments. When the weathering slowed, CO2 built up again. When it increased, CO2 fell. A natural thermostat, managed not by intent, but by interaction. And life played its role too. Methanogenic microbes, living in the oxygen-free depths of the ocean and in the wet, warm muds near volcanic coasts, produced methane as a byproduct of their metabolism. This methane rose into the atmosphere, bolstering the greenhouse, balancing the faint light of the sun. Yet the stability was never complete. There may have been cold spells, times when ice crept farther across the ocean's surface, when cloud cover thickened, when volcanic eruptions dimmed the sky for years or decades. But these were pauses, not endings. Life held on. The warmth always returned, like memory, like breath, like the tide. The balance between heat lost and heat trapped was never perfect, but it was enough. Enough to allow water to remain liquid, enough for life to continue, enough for Earth to remain habitable long before the sky turned blue. Imagine the feeling of that world, the warmth of sunlight filtered through thick clouds, the heat of volcanic vents rising through water, the thermal inertia of a planet still cooling from its birth. The surface of the sea may have steamed in places, the air above coastal pools thick with mist, and always microbes stirred in those pools, making use of every gradient, every pocket of energy. There is beauty in their perseverance, in their capacity to endure not through complexity, but through resilience. They were small, but they knew how to wait. In this world, sunlight still mattered. It did not arrive in overwhelming waves, but in softened glows. It was a gift that microbes had learned to use, bending it into sugar, into structure, into life. The invention of photosynthesis, First, the anoxygenic kind that used sulfur and iron, and then the great leap to oxygenic photosynthesis was a transformation greater than any visible structure, any mountain or river or sea. It was the quiet redefinition of energy. Light, once just heat and pressure, became nourishment, and as photosynthesis spread, the atmosphere responded. Slowly, delicately, oxygen began to rise. It did not surge. It crept. It crept into the oceans first, forming localized oases where new metabolisms could take hold. It met iron and formed rust. It met methane and broke it down. And eventually it began to gather in the sky. When oxygen met methane, it formed carbon dioxide and water, less potent greenhouse gases. The Earth began to cool slightly. A new feedback had entered the equation. A balance that had once favored methane began to shift toward oxygen. The chemistry of the atmosphere began to reflect the chemistry of life itself. And through all of this, the Earth, it was listening. Its crust grew thicker. Its plates moved more predictably. Its volcanoes, while still frequent, began to erupt in cycles, not chaos. Subduction zones recycled the crust, creating chains of volcanoes that belched gases into the sky and built up new land. Island arcs formed and collided. Protocontinents grew, weathering increased, nutrients were carried into the sea. Life, in turn, expanded, flourished, adapted. In time, the feedbacks would become too strong. Methane would decline, and with it, some of the greenhouse protection that had warmed the Earth under the faint young sun. The planet would tip into its first great ice ages. Oxygen would rise more dramatically. The sky would begin to open, to clarify. The blue would arrive slowly, washing away the sulfurous haze, revealing stars for the first time to a world that had never truly seen them. But in the late Archean, that moment had not yet come. The balance still held. The Earth was warm, not from sunlight alone, but from its own ingenuity, from the interactions of rock and air, of ocean and microbe. It was a warmth earned by persistence, by countless small acts, each cell, each molecule, each beam of light put to work not in haste, but in patience. And tonight, as you lie in the quiet space between waking and sleep, you carry that warmth still. The heat in your chest, the electricity flowing in your nerves, the photosynthetic energy stored in the food you've eaten, it all traces back to those first exchanges. You are the answer to a question life asked 3.5 billion years ago. Can it endure under a faint sun? Can it grow, evolve, thrive? The answer is you. So let your breath rise and fall like the greenhouse gases of long ago. Let your warmth be a memory of a younger Earth. Let yourself drift into the soft, golden haze of that sky, into a sea that never froze, into a planet that balanced on the edge of light and shadow and found its way forward. The light was faint, but the future was already burning. Now let your thoughts narrow, not outward into the sky, or deep beneath the crust, but inward toward the smallest known fragments of Earth's memory. Imagine holding in your palm a crystal no wider than a grain of sand, translucent and colorless, and yet older than the continents beneath your feet. This is a zircon, not shaped by life, but a keeper of life's first hints. Within its lattice are whispers of a time long before breath, long before bone, long before eyes opened beneath any sun. Zircons do not live, but they record. They are timekeepers, bearing isotopic signatures locked in their crystal hearts that allow us to listen to the earliest murmurings of habitability. In them, Earth's first water is revealed, its first crust traced, its first softness imagined. Some zircons are over 4.3 billion years old, more ancient than the oldest rocks, preserved only because they were carried forward, eroded from their original homes, and reassembled into younger stone. They are fragments of an earlier world, a world even more mysterious than the Archean. But in the late Archean Eon, zircons still form, still grow quietly in pockets of magma, in the slow cooling of granitic crust, deep beneath the land masses that are learning to become continents. Their chemistry captures the temperature and pressure of their formation. Their ratios of oxygen isotopes whisper of the presence of liquid water. In a time with no diaries, no drawings, no voices, zircons speak in the only language that survives deep time, elemental balance. To a wandering mind, these crystals are nearly miraculous. They are not merely old, they are precise. Their internal clocks tick with uranium decaying to lead, in ratios that do not forget. They tell us when the crust solidified enough to support them, when the surface cooled enough for rain to fall. Some suggest, startlingly, that liquid water was present not just in the Archean, but even in the Hadean, in Earth's first few 100 million years. If true, it means that habitability came swiftly, that the conditions for life may have begun almost as soon as Earth itself coalesced. But here, in the late Archean, we no longer need only zircons to trace the planet's softness. The signs are everywhere now, in sedimentary rocks that form from the settling of grains in rivers and oceans, in the layered structures left behind by microbial mats, in the thickening bands of iron-rich stone that chart the slow rise of oxygen. And yet zircons remain, silent, patient, watching. Imagine them now, forming deep underground, in molten chambers far beneath the surface, tiny prisms crystallizing out of silicate melts. They form only under specific conditions, when there is zirconium in the melt, when temperatures are just right, when the chemistry allows it. Once formed, they are nearly indestructible. Fire cannot melt them again easily. Pressure does not crush them. Water cannot dissolve them. They are, in a way, immortal particles, capable of traveling through geologic cycles untouched. They move through the earth not by walking or flowing, but by being carried, eroded from one rock, washed down a stream, buried in a delta, metamorphosed into a new stone, melted again, and yet still surviving. Each journey adds to their story. Each layer of overgrowth, each slight change in chemistry, is another paragraph written in their silent book. Some are recycled through 3 or 4 major crustal events, surviving hundreds of millions of years between each appearance in the rock record. No living creature can carry memory so far, so cleanly. And yet, for all their endurance, zircons are not symbols of stillness. They are part of Earth's dynamism. They form in magmas that rise, in crusts that melt, in regions where plates collide and generate the heat and pressure needed to drive continental evolution. They are products of change, not stasis. And they are more than witnesses, they are tools. They allow us to reconstruct the temperature of ancient magmas, the presence of water in early crust, the formation of the first continental nuclei. So when you hold a zircon in your mind, hold also the context of its birth. A crust thickening beneath a volcanic arc, granite forming in deep chambers, subduction zones humming far below, rains falling on mountains that rise and erode with equal grace. Life, though still microbial, clings to the surfaces of this world. It does not yet shape minerals, but it begins to influence sediment, to alter chemistry, to leave traces. Over time, life will begin to shape zircons too, not directly, but by changing the world in which they grow. Life will oxygenate the atmosphere, alter the way rocks weather, influence the chemical signature of future melts. In the Proterozoic and beyond, zircons will carry not just thermal and chemical stories, but biological ones too. But for now, in the Archean, they are still mostly silent witnesses, carried in riverbeds, locked in granites, buried in metamorphic belts. They do not speak, but they are not mute. To those who can listen, they recount the earliest whispers of oceans, the beginnings of crustal complexity, the slow emergence of a planet capable of dreaming. Tonight, as your breath slows and your body settles into the quiet rhythm of sleep, think of the small things that endure, not the towering peaks or the storm filled skies, but the tiny fragments that survive time without complaint. The cell that copies itself, the microbe that finds a way, the zircon that forms in silence and outlasts all living things. These are the keepers of continuity. These are the threads that hold the Earth's memory together. And you, with your heart beating steadily, your breath rising and falling, are woven into that same continuity. You carry minerals older than language. You inherit a story written not in ink, but in isotope. You are not merely present in time. You are time, made aware of itself. Let that thought cradle you now. Let it soothe the restless parts of you. Let the quiet clarity of zircons settle like dust across your dreams. The earth remembers everything, and you, in sleeping, become part of that memory. Let your breath fall into rhythm now with the gentle pattern of something barely perceptible, something that takes shape only over the slow unfolding of eons, a ripple of oxygen moving through water, a presence so faint that for millions of years it barely changes anything at all, and yet eventually it changes everything. Drift now into that invisible tide, into the soft ascent of a molecule that was once a stranger to air. Oxygen, exhaled by simple cells, dissolved first in water, then slowly pushed outward into the world above. At first, it met only resistance. The ocean swallowed it, binding it to iron, to sulfur, to compounds eager to react. And once those were saturated, it began to rise, not dramatically, not in a rush, but with the unshakable patience of life itself. In the Archean, oxygen was not yet life-giving in the way we think of it today. It was, to many early organisms, a threat, reactive, corrosive, disruptive to the finely tuned chemistries of anaerobic metabolism. For countless microbial lineages, oxygen spelled death. It damaged their enzymes, poisoned their environments, and yet other lineages adapted. They developed antioxidants, mechanisms to neutralize reactive oxygen species, pathways that not only tolerated oxygen, but began to use it. Slowly, cells learned to extract more energy by breaking down sugars in the presence of oxygen, unlocking a power source far more efficient than fermentation or sulfur-based respiration. In doing so, they stepped toward complexity, toward possibility, toward the eventual architecture of multicellular life. But in this world, the oxygen is not yet in the air you might imagine. It remains in shadow, patchy, uneven, emerging first in small enclaves in the surface ocean. The deep waters are still anoxic, filled with iron and hydrogen sulfide, their chemistry hostile to oxygen. The interface between these zones becomes a place of tension and opportunity. Life diversifies there, not wildly, but gradually. New forms of metabolism evolve to exploit the shifting gradients. Life does not march forward, but it adapts with exquisite sensitivity to change. And the oxygen is not idle. It begins to react with methane in the atmosphere, breaking down a greenhouse gas that had kept the earth warm beneath the faint sun. With methane declining, the climate becomes more vulnerable to fluctuations. There may have been short lived ice ages, moments when ice crept further from the poles, perhaps even reaching into the tropics. These were not the snowball Earths of later eons, but they were warnings of change to come. The atmosphere, once thick with haze, begins to thin. The light changes. The colors of the sky shift. With every molecule of oxygen that rises, the veil over the stars becomes more transparent. And yet, for all its transformative power, oxygen does not announce itself. It is not loud. It does not sweep across the planet in a wave. It creeps, it flickers, it rises and pulses and falls again. There are false starts, times when it accumulates, only to be consumed again by the vast chemical hunger of the world. The crust absorbs it, the oceans bind it, volcanic gases counteract it, and then life releases more. It is a slow conversation between biology and geology, between what breathes and what breaks down. One of the most profound changes it brings is in the very color of rocks. Before oxygen, the surface rocks are dark, rich in unoxidized iron and other reduced minerals. But as oxygen levels rise, even slightly, iron begins to rust in place. Red beds form, sandstones stained with hematite, indicators of oxidative weathering. These colors, these pigments written in stone, are not decoration. They are signals, flags planted by the slow, persistent rise of oxygen. They appear first in isolated places, then more broadly. Eventually, they will cover continents, turning the Earth's surface into a mosaic of oxidation. The great oxidation event, which is still to come, will not arrive like a trumpet's call. It will be slow, stretched across tens of millions of years. But its seeds are here, in the late Archean, in the bubbling mats of cyanobacteria, in the slow depletion of iron from the oceans, in the first oxidation of sulfur, which alters the balance of the global sulfur cycle and leaves a fingerprint in the isotopic record. These changes are small, quiet, and yet they are tectonic in their implications. They mark the moment when life begins to write its influence into the sky, and the sky is beginning to notice. The methane haze, once thick and warming, is breaking down. The blue of the atmosphere begins to peek through. Stars, long hidden, begin to shimmer more clearly at night. The moon reflects more brightly on calmer seas. The earth begins to resemble itself, though it is still not ready for breath or leaf or bird. The atmosphere is not yet breathable. Oxygen hovers at perhaps 1% of present levels, but it is enough to change the rules, enough to tilt the scales of evolution. Meanwhile, life itself continues to explore. The boundaries of oxygenated zones become sites of innovation. Some microbes begin to specialize in exploiting these margins. They shuttle electrons along longer chains. They evolve more efficient ways to capture light, to store energy. Horizontal gene transfer accelerates, sharing useful genes across lineages, like whispered secrets in the dark. The toolkit of life becomes richer, more versatile. Cells begin to compartmentalize more efficiently. The scaffolding for complexity is quietly assembled, and beneath it all, Earth itself is preparing for a new chapter. the crust has thickened further. The first large continental blocks are nearly in place. Supercontinent cycles are beginning to emerge, though they move slowly, on scales almost too vast to comprehend. The interior of the planet continues to cool. The mantle convects with greater organization. Plate tectonics becomes more regular, more predictable. The geological engine of the Earth, once erratic, is becoming steady. It will drive mountain building, volcanism, ocean formation, and through all of it, life will respond. But tonight, none of that needs your attention. Tonight, it is enough to imagine the quiet rise of oxygen, that gentle tide lapping at the edges of an anoxic world. It is enough to picture a sky growing thinner, stars just beginning to reveal themselves to a planet that had never seen them. It is enough to know that every breath you take was made possible by those patient microbes, those layered mats of cells that never knew lungs or eyes, but still gave you the gift of air. So breathe softly now. Let the oxygen fill your lungs and remind you of that ancient generosity. Let the rhythm of life's slow ascent calm your thoughts. Let the stillness of the Archean night, lit by a faint young moon, hold you. The oxygen is rising. The stars are returning. The world is learning to breathe. And you, wrapped in that memory, are already part of its future. Now fall quietly with the rain, not the cold bursts of a modern storm, not the gentle tapping of droplets on rooftops and window panes, but the slow, steady descent of water through an ancient sky, through thick, methane-laced clouds that hung low over a world not yet green. Imagine it falling in long curtains, warm and weighty, into a land of volcanic stone and shallow seas. This was the reign of the Archean, unceasing, elemental, and unimaginably ancient. It had been falling for billions of years, ever since the steam of Earth's infancy condensed and the oceans were born. And even now, in the late Archean, it continued, each drop a sculptor, each storm a quiet force in the shaping of continents. This rain fell on landscapes still raw, where granite and basalt jutted into the sky with no cover, no canopy of leaves, no carpets of moss or ferns. The rivers it fed were wild and untethered, cutting deep channels into the land, their muddy waters rich with the dissolved breath of stone. These waters, carved through mountains not yet softened, wearing down the highlands built by colliding crotons, carrying sand and silt to the sea, layering the ocean floor with sediments that would harden into shale and sandstone, into memories. There were no tree roots to slow the erosion, no soils to hold the land in place. Gravity and water worked unopposed, reshaping the surface again and again, feeding the chemical engine of weathering that pulled carbon from the sky and ferried it downward into the earth. In this long process, the rain was more than water. It was chemistry in motion. As it passed through the atmosphere, it absorbed gases, carbon dioxide, sulfur dioxide, even traces of ammonia, becoming weakly acidic. This gave it power to react with the minerals in rock, to dissolve silicates, to free ions that would travel with the rivers, feeding the deep chemistry of the sea. The weathering of newly exposed land released calcium and magnesium, which in turn helped to lock away carbon as carbonate minerals in the ocean. This was not a deliberate act, not a balancing mechanism by design, but a consequence of interaction, of contact between air and stone and water. Yet it formed a feedback loop, a planetary breath. When carbon levels rose, the Earth warmed, The rain fell more heavily, weathering increased, and carbon was drawn down again. When carbon fell, cooling followed, rains slowed, and the drawdown weakened. This quiet dance helped to steady the planet beneath a faint young sun, and always the rain returned to the sea. It fell on the land, wandered across slopes and through fractures, and then gathered itself into brooks, into streams, into winding rivers that threaded the landscape. These rivers spread outward, sometimes disappearing into temporary lakes, sometimes merging into deltas that reached into the shallow oceans. In the late Archean, the continental margins were wide and flat, not yet fringed with cliffs or reefs, but rich with muddy flats where microbial mats spread like tapestries across the wetness. These regions, where fresh water met salt, were among the most active interfaces on the planet. Here, the rain carried nutrients from the land to the sea, and here, in turn, life responded. Microbial colonies thrived in these brackish waters, layering themselves into dense mats that trapped sediments and built stromatolites, those strange domed structures made from layer upon layer of living and dead cells. The rain sustained these mats not by watering them, as it would later sustain forests, but by feeding them minerals, by keeping the interface between land and sea rich and dynamic. These mats created their own microclimates, their own oxygen bubbles, their own slippery ecosystems. They were not fast growing, not beautiful in a traditional sense, but they were enduring, and through their photosynthetic labor, they continued to change the world. The atmosphere, affected indirectly by this endless cycle of rainfall and weathering, began to shift even more. As the carbon dioxide was drawn down and more oxygen was released by photosynthesis, the air became clearer. The rain, falling from these changing skies, began to reflect a different chemistry. The world was still not one you could breathe in, still unkind to lungs, but it was no longer as thick, no longer as veiled. There may have been days when, through the thinning clouds, the sun's disk appeared not just as a pale suggestion, but with true definition. There may have been nights when the moon's reflection danced more brightly across the water, when the first stars pierced the sky with cold, brilliant light. And just as the rain softened the earth's surface, it also carved deeper into its crust. It seeped into cracks, into porous rock, feeding hydrothermal systems far below. This water, heated by the planet's interior, returned to the surface through vents and geysers, enriched with metals, with sulfur, with the building blocks of more chemistry. Around these exits, life gathered too, chemosynthetic microbes that fed not on sunlight, but on the energy released by reactions between water and rock. Those too were fed, ultimately, by rain, by the continuous falling of sky into stone, and the rising again of water transformed. So rain was not merely a phenomenon, it was a force of connection. It joined air to land, land to sea, sea to life, and life back again to air. It blurred boundaries, made all things continuous. It carried messages across the surface of the planet, over the shoulders of hills, into the mouths of rivers, down into ocean basins, where it joined the slow sedimentary poetry of the sea. Over time, these sediments would be buried and compressed, folded and lifted into mountains once again, exposed to the sky, and the cycle would continue. Rain never ends, it only begins again. And now, as your breathing slows and your thoughts grow misty, let yourself fall with that rain. Imagine drifting downward through ancient clouds, through air thick with the breath of volcanoes, past the glimmer of a rising moon, until you land softly on warm stone. You feel the touch of a droplet that has traveled far, and in its coolness is memory. A memory of skies you never saw, of rivers that no longer flow, of worlds that existed before dreams. You are part of that journey. The water in your blood once fell as Archean rain. The minerals in your bones were dissolved in rivers that carved the first paths through empty lands. You do not simply stand on the earth, you rise from it. Every heartbeat echoes the rhythm of ancient rainfall. Every breath is a continuation of a cycle begun billions of years ago. So close your eyes. Let the soundless rain of the past wash over you. Let it soothe you, carry you, fold you into the stillness of a world that once knew only water and stone and sky. You are safe in its rhythm. Now allow yourself to rise slowly, softly, as if borne upward by a warm ocean current in the quietest morning, not to escape the depth, but to see it anew from above. Let the mists part and the ancient world stretch out beneath you, not in the stark lines of maps or borders, but in hues of warmth and softness, in gradients of time. You are hovering now over a planet that has changed without ever meaning to, that has become more than stone and sea. This is still the Archean, but it is no longer the same Archean you entered when this story began. It has shifted, not abruptly, but by the slow accumulation of light, of oxygen, of time's patient adjustments. You are witnessing a world that is readying itself for something it does not yet know how to dream. Look down upon this earth. The continents, once scattered fragments, have grown larger, some perhaps converging. Their margins are wide and low, not jagged cliffs, but gentle platforms dipping into shallow seas. The water is still colored with minerals, still rich with the signatures of unseen life, but its chemistry is changing. The iron that once gave it a rusty hue is nearly gone now, locked away in bands of stone. The ocean is clearing subtly, just as the atmosphere above is clearing. The sunlit zones stretch farther, and the light reaches deeper. Where once the sea was a thick broth of metals and murk, it is now beginning to become the ocean we will one day recognize, not yet blue, but on its way. From this high place, you can trace the outlines of ancient coastlines, where microbial mats press against the land like a second skin, their edges glinting in soft light. You can see vast tidal flats, where the rhythm of the moon continues to sculpt the shore in its slow, celestial breath. You can feel the cooling of the earth beneath the crust, the mantle no longer raging with the violence of its youth, but humming with the steady power of convection. Above, the sky has thinned enough to carry wind in more familiar patterns. Breezes now pass over landforms, tracing new paths, shaping dunes where no plants yet root the sand, and in the air, in trace amounts but growing, is oxygen, not yet the breathable kind, not yet enough for lungs, but enough to matter, enough to leave traces in sulfur isotopes, in red-stained soils, in the oxidation of minerals once untouched by air, enough to begin the slow transformation of the biosphere to prepare the world for the next chapter, the Proterozoic, the long age that will see cells develop nucleuses, that will see the rise of complexity. But that is still ahead. The Archean is not yet finished. It is exhaling its last long breath, its twilight years painted in warm tones of transformation. And what a twilight it is. There is no sunset here, no ending, only a long blending of before and after. The boundary is not marked by catastrophe but by continuity. The microbes that dominated the early Archeans still thrive. They are the same in many ways, simple, persistent, unhurried. But some carry new genes now, new pathways, new responses to a world that is changing around them. Genetic material has shuffled between species countless times. Mutations have stacked. Molecules have tested and discarded thousands of possibilities. And still, everything moves at the pace of sediment falling through calm water. If you were to lower yourself again to the surface and walk along one of these silent shores, though no feet have walked here, not yet, you might see the faint colors of microbial colonies spreading across wet stone, the glint of pyrite crystals oxidizing under an atmosphere no longer fully reducing, the slow pulse of a tidal inlet filling and emptying like a breath held and released. And you might feel, not just imagine, but truly feel the presence of time here, not as a line, but as a depth. Each grain of sediment carries a memory. Each molecule of water has fallen as rain, risen as vapor returned. Each drop is part of a cycle that never ends, only expands. Above you, the sky has changed, though it is difficult to say exactly when. The orange haze of methane is thinner now. The first clear blue may begin to flicker through the clouds on certain days, particularly in the dry interiors of the emerging land masses. The color blue, so familiar to us, so comforting, has not always been part of the world. It is arriving now, slowly, alongside the stars, which now begin to shine through at night in greater numbers. The stars, always present but once hidden, are now becoming visible. Earth is beginning to see the universe, and the moon, still retreating, still holding the tides in its invisible embrace, still reflecting sunlight in that same steady glow, continues to mark the rhythm of life. Days are longer now, nearly 20 hours. The planet spins more slowly. The nights stretch deeper. The tempo of the world is slowing. This longer rhythm gives more time to photosynthesis, to repair, to division, and perhaps, in ways we do not fully understand, it gives more time to becoming. You are drifting now at the very edge of the Archean Eon. Behind you stretches more than 1 billion years of change, unseen, unspoken, but written into every atom, every rock, every cell. Ahead lies a new chapter. The oxygenation of the atmosphere will soon reach a threshold that shifts everything. Some life will vanish, some will adapt. Eukaryotes will appear, with their internal compartments, their more organized DNA, their endless potential for diversity. But that is another dream, a gentler unfolding, even slower, even richer. Tonight, as your breath slows and the darkness deepens around you, know that you have wandered through a time most never feel. You have walked where no eyes had yet opened, breathed in the scent of air before leaves, touched the skin of oceans that held only microbes. You have listened to the heartbeat of a young planet, still warm from its birth, still patient with itself. And in doing so, you have felt something true and quiet and vast. The Archean does not end. It simply fades into what comes next, like a long dream that softens before waking, leaving only the feeling of motion, of warmth, of change. And now, as you rest, as your thoughts dissolve into the dark, you too can slip into that dream, not to end it, but to carry it forward. The world is still becoming, and so are you.